Namaskar, Suprabhat, a very good morning to all. Today, the 14th of July 2025, marks an important milestone for the Central Region of Atomic Minerals Directorate. With the rising sun this morning, a newly constructed auditorium, christened as Dr. D.N. Wadia Auditorium, became a part of the AMD Central Region family. This addition is synchronous with the 75 glorious years of AMD and is not only the culmination of hard work and a shared vision, but also the symbol of a new journey and future successes. To mark this beginning, a memorable one, a theme workshop has been organized today. The topic of the workshop is Atomic and Critical Minerals Resources, Geological Insights from Central India. On behalf of the workshop organizing committee, I feel privileged to be on the dais today, extending a warm welcome to all the luminaries from Atomic Minerals Directorate, both serving and retired, as well as from various scientific, government organizations and public sector units, Geological Survey of India, Indian Bureau of Mines, Mineral Exploration and Consultancy Limited, MOIL Limited, Directorate of Geology and Mining Chhattisgarh, RTM Nagpur University, Vishweshwaraya National Institute of Technology, Jawaharlal Nehru Center for Aluminium Research, Development and Design, Maharashtra Remote Sensing Application Center, Raman Science Center, National Environmental Engineering Research Institute, Central Mine Planning and Design Institute, Central Institute of Mining and Fuel Research, CPWD. And to witness this momentous occasion, we have with us today Director AMD, Shri Dheeraj Pandey Sahab, Additional Director Operations to AMD, Shri Prem Kumar Sharma Sahab, Regional Director Central Region, Shri Shrikant Manthanwar Sahab, Head PMSG AMD, Shri NK Panda Sahab, Head ESG AMD, Srimati Sujata Mudliar Ma'am, all the in charges and officers of the region, retired Additional Director, Regional Director, Deputy Regional Director, Senior Officers, from the invitees, Shri Dinesh V. Ganveer, Additional Director General GSI Central Region, Shri P.K. Bhattacharya, Controller of Mines, Indian Bureau of Mines, Dr. A.K. Raina, Head of the Department, SIMFER, Shri Om Bijlani, HOD, CMPDIL, Shri D.M. Kolte, Director, MRSAC, and many other dignitaries from these organizations. I extend a warm and hearty welcome to you all on this occasion. It is also a pleasure to have dignitaries from AMD, Additional Director Operations 1, Additional Director R&D, Regional Directors of other regions, Heads of various groups, in charges of investigations and laboratories, officers both retired and serving, connected with us through virtual mode. I extend a warm welcome to you all. It is a pleasure for us to have Director AMD, Shri Dheeraj Pandey Sahab, as the chief guest for the inauguration of this theme workshop. Sir has been a leading voice in the department for his expertise, and it's a pure bliss for us to have him here today as the chief guest. Additional Director, Operations to AMD, Shri Prem Kumar Sharma Sahab, is the guest of honor for the occasion. Sir has always been a strong supporter of all the developmental activities happening in the region. Moving forward, I now request Regional Director, Central Region and Chairman of the workshop, Shri Shrikant Manthanwar Sahab, and Convener of the workshop, Shri Rajiv Ranjan Sahab, to kindly escort the Chief Guest, Director AMD, and the Guest of Honor, Additional Director Operations 2, to the dais. Thank you, sirs. To officially mark the beginning of today's inauguration, we will now proceed with the lighting of the lamp, symbolizing the start of a bright and prosperous journey ahead. As we all know, lighting the lamp is always a symbol of wisdom, knowledge, and positivity. I request our chief guest, guest of honor, chairman, and convener of the workshop to please come forward for the lamp lighting. I request Srimati Pranali to assist. Thank you, sirs. Keeping in line with the green initiatives taken by Government of India, I request Regional Director and Chairman of the workshop, Shrikant Manthanwar Sahab, to present a sapling to Chief Guest Director AMD and Guest of Honor Additional Director Operations to AMD and formally welcome them. I once again request Shri Manthanwar Sahab to felicitate the guests from the invited organizations, and I request Sir to please come in the hall. Shri Dinvesh Ganveer Sahab, Shri P. Bhattacharya Sahab, Dr. A.K. Raina, Shri Om Bijlani, Shri D.M. Kolte. Thank you, sir. I request convener of the workshop, the Rajiv Ranjan Sahab, to kindly felicitate the chairman of the workshop, the Shrikant Manthanwar Sahab. Thank you, sir. I now call upon Secretary Organizing Committee, Dr. M. Sridhar, to kindly honor the convener of the workshop, Shri Rajiv Ranjan. Dr. M. Sridhar, Secretary Organizing Committee, kindly felicitate the convener of the workshop, Shri Rajiv Ranjan Sahab. Thank you, sir. We all are aware that atomic and critical minerals are essential for various technologies and industries, including nuclear power, electronics, and clean energy. In the current scenario, where the world is focusing on reducing the carbon footprints and transiting towards clean energy, the topic for today's workshop, Atomic and Critical Mineral Resources, Geological Insights from Central India, stands justified. Moving forward with the program, I request Regional Director, Central Region and Chairman of the workshop, Sri Shrikant Manthanwar Sahab, to deliver the welcome address.
Thank you, Nishma. Respected chief guest, today's workshop, chief patron and our beloved Honorable Director, AMD, Shri Dheeraj Pandey, guest of honor and patron, Honorable Additional Director, Shri Prem Kumar Sharma ji, Additional Director, OP1, Shri Mayank Agarwal, and Additional Director, R&D, Shri KL Mundra Sahab, who have joined virtually. I also extend a special welcome to Shri Dinesh Ganvir, ADG GSI, Nagpur, Shri P.K. Bhattacharya, Controller of Mines, IBM, Shri A.K. Saxena, CMD Moil, and Mr. Kolte, Dr. Kolte from MR SAC, Dr. Raina from Simfer, and my friend from CMPDIL. Your presence enriches this gathering, and we are grateful for your esteemed presence. Respected dignitaries from our vibrant geological fraternity, you have graced this event by their august presence. Respected and distinguished former colleagues from AMD, they have rendered their invaluable service to the Directorate and the nation. Respected guests who have joined today's proceedings virtually, DGM Chhattisgarh, Mr. Sanjay Kankane, Joint Director, GDM Chhattisgarh, Professor Kirti Kumar Randive from RTMNU Nagpur. Namaskar and a very warm welcome all the distinguished scientists, researchers, and participants. We are honored to mark this significant occasion with the inauguration of the Dr. D.N. Wadia Auditorium. Dr. D.N. Wadia joined among Indian geologists and a guiding force in the early days of AMD. truly laid the foundation for mineral exploration in independent India. It's my distinct pleasure to greet you today at this theme workshop on Atomic and Critical Mineral Resources, Geological Insights from Central India, ACMR 2025. On behalf of the organizing committee, I extend a heartfelt welcome to each and every one of you. On this opportune occasion, I want to briefly set the stage for what promises to be an engaging and insightful exploration into a topic of immense geological and strategic importance. Central India, as many of you know, is a geological marvel. Its ancient cratons, mobile belts, protozoic basins, and extensive magmatic provinces hold the key to understanding various technothermal processes. More importantly, for current discussions, these geological formations are also the repositories for vital mineral wealth, particularly atomic and associated critical minerals. The theme of this workshop underscores the critical role that geological insights play in the discovery, understanding, and sustainable utilization of these resources. When we speak of atomic minerals, we are of course referring to elements like uranium and thorium, essential for nuclear energy, a clean and powerful energy source that is becoming increasingly vital in our quest for sustainable development. And then we have critical minerals, a diverse group that includes rare earth elements, lithium, niobium, tantalum, and many more. These are not just obscure elements in a periodic table, they are the bedrock of modern technology. From our smartphones and the electric vehicles to renewable energy systems and advanced defense technology, critical minerals are indispensable. Their secure and sustainable supply is a matter of national and global strategic. Central India, with its rich geological tapestry, offers a unique natural laboratory for studying the genesis and distribution of these minerals. From the unraveling of high-grade metamorphic terrains to the exploration of pegmatites and alkaline complexes, the region presents a wealth of opportunity for cutting-edge research. Today, we'll have the privilege of hearing from leading experts who have dedicated their careers to understanding these complex geological systems. We'll dwell into detailed case studies, discuss innovative exploration techniques, and explore the latest advancements in mineral characterization. This workshop is not just about presenting data. It is about fostering collaboration, sparkling new ideas, and collectively advancing our understanding. We are also honored to celebrate this in the 75th year of AMD's foundation, as we are celebrating 75 years of AMD. It is a big privilege for us to have this workshop in AMD Central Region now, Nagpur. It is my firm belief that this workshop shall provide platform to discuss on India's atomic and critical mineral arena, emphasizing their exploration in Central India. It is through such collaborative efforts that we can unlock the full potentials of Central India's mineral resources and contribute to a more sustainable and technologically advanced future. The verse from Rigveda is truly relevant. Ano Bhadraha Kravato Yantu Vishwata. Let the noble thoughts come to us from all and every directions of the universe. once again, a very warm welcome. Let the geological insights from Central India enlighten our minds and inspire our discussion. Dhanyavad. Jai Hind.
Thank you, sir, for your welcome address. I now invite the guest of honor, Additional Director Operations to AMD, Shri Prem Kumar Sharma Sahab, to address the audience.
Namaskar and good morning to all of you. Respected beloved Director AMD, Shri Dheeraj Pandey, Regional Director Central Region, Shri S.R. Manthanwar Sahab, and the convener of the workshop, Shri Rajiv Ranjan ji, our senior retired officers, many were the regional directors of the region and many were the in charges, and they have worked in the diverse terrains of the central India as well as in other parts of the country. They are the stalwarts of AMD, dignitaries and officials from the different geological and mining sector organizations, dear colleagues and officers of Central Region, and also the officers and the heads who have come from the AMD headquarters, Hyderabad. I really feel very happy and privileged to attend this theme workshop, Atomic and Critical Mineral Resources, Geological Insights from Central India, being organized by the Central Region of AMD at this today inaugurated Wadia Auditorium. Really, Central India is having the many favorable geological terrains. It is having proterozoic basins and the Total Nagpur granitic nicely complex and many major structural features which are passing through the Central Indian cratons. So there are many sites which are favorable for these atomic and the critical minerals. The importance of the atomic and critical minerals rests on that the huge target of the atomic energy we are having for this clean and green energy of the 1000 megawatt by the 2047. So you can understand that what will be the requirement of the nuclear fuel for it. And critical minerals, as already told by our regional director, they are very important in the many industries we are using in day to day, and everybody knows about it, how important they are, and their concentration supply from a particular place at present. So it is critical for the India and need to be explored and exploited for our industrial different uses. The theme of workshop perfectly fits the need of the time. As I told that in the different mineral sectors, the critical minerals and in atomic energy, the atomic minerals demand is going to be increased manifolds in the years to come. This workshop is also a platform to discuss the various aspects of the atomic and critical mineral resources and their status, where we stand and the different geological favorable terrains and the state of art technologies which we are using, and there are many developments in those technologies in the recent years, and we have to use those technologies to augment our resources
से अपनी माँ के अतीत के बारे में जानने की कोशिश कर रही थी। आखिरकार आज की जिंदगी से
moderated and modified after the amendment of the MMDR Act. So although some of the 6 minerals have been removed from the atomic minerals list, but still AMD has not reduced the activities for exploration of those minerals. In fact, we have increased our activities for these critical minerals, especially rare earths and lithium. So during my keynote, probably I'll give you a glance of what we have been doing in this front. And recently, I would like to just delve upon the importance of these so-called critical minerals. Why India is now pursuing these minerals at such a rapid rate. You remember a week back we had the BRICS summit in Rio de Janeiro, Brazil, where PM Modi made a very significant statement. He said critical minerals are now being used as weapons of economic warfare. How correct his statement is. You would now see the Ukraine war, it is being fought because of these minerals only, because Ukraine is a large supplier of titanium, lithium to European countries. And the first occupation of Russian forces was in the area which are rich in titanium resources. So currently, most of these wars are now, the Afghanistan war, way back, Russia, when you talk about Afghanistan, it was not out of something that they would establish their presence in the Southeast Asia or Asian continent. It was just after the minerals. Afghanistan boasts of a huge catch of minerals. So now all future wars, if ever they are fought, they are going to be fought for these minerals. And as Chinese Premier long back, he had announced that rare earth is the new oil now. So besides that, a couple of days back, President Trump, he has now imposed a tariff of 50% on copper imports. Why is that? I mean, it sends shockwaves around the world. 50% imports on copper, tariff on copper. Just because he wants to develop the indigenous industry. How much will be successful, how much time it will take, how much more money US will spend on importing copper after these tariffs are. But these are the kinds of things that are now developing in the world. And recently, Siemens, the German firm which produces most of the wind turbines in Europe, now it has stopped sourcing RE magnets from China after the Chinese backed out for recently when they said that they won't be providing the heavier rare earths or the magnet supply was the US and Japan. So these kinds of new geopolitical scenarios are being played out in the world, and India is not much behind. The Quad group, you know, the India, Australia, Japan, and US are thinking of establishing an HRE hub in Visakhapatnam now. So we are also in the forefront of these activities. And similarly, in this particular backdrop, because I spoke about all these things because I wanted to make a background for the kind of team workshops that we have been organizing. These are the this is the importance of these minerals now. No country can be left behind. Whether there is its importance, whether it is in defense or space or strategic sectors like atomic energy, whether it is in medical field, whether it is agriculture, whether it is transport, whether it is industry, every bit of every sector now realizes the importance of minerals, especially the critical minerals. So we have to develop indigenously this mineral industry in the country. We have been in the background for a long time, and now the country realizes the importance of geoscientists. Nowadays, the focus is on this national critical mineral policy, and over the top of that, the government has also announced the national nuclear mission, where we have to generate almost 100 gigawatt of power by 2047 through energy. So again, that would require a huge supply of indigenous uranium. Of course, uranium is available in the world market now. Presently, it's almost at an all-time high of $79 per pound. It's an increase of 10% month on month. So that the industry is also realizing that yes, if you need clean energy, you need baseload energy. Nuclear energy cannot be far behind. In fact, it has to play a major role. Rest the energy derived from renewables, maybe that will form a part of the optimal mix. But the major share has to go to nuclear if we have to have a low carbon economy and low carbon electricity. We have to achieve the goals of net zero. So with this backdrop, I think this is an important workshop. And I was pleased to read about the invited lectures from the dignitaries of various organizations, all center around the major theme of these critical and strategic minerals. And of course, will be a great insight into the central India, because central India has a wide variety of rocks, favorable rocks rather, and favorable geological terrains, which can hold these kinds of critical mineral deposits. And, once these talks are delivered, I think with the kind of interaction now that Central Region has with the other geological, Nagpur especially, when we have to now come together, have a close-knit group, and interact frequently and share data, which is already being done now thanks to the NGDR portal of GSI. Is a huge application and benefiting to all stakeholders. AMD is also contributing to that data portal now. So with these words, I again thank Parji for inviting us to the symposium, and I look forward to a great deliberation. Thank you.
Thank you, sir, for your words. The workshop being held today is an amalgamation of keynote addresses and research presentations. All these have been compiled and published in the form of proceedings. The unveiling of this abstract volume will be done now by our chief guest of honor, chairman, and the convener of the workshop. Thank you, sirs. I now request the dignitaries on the dais to please be seated among the audience and enjoy the audio-visual presentation depicting the journey of the Central Region AMD. An honor for us that many of our retired officers are here with us today to bless, because without their blessings, nothing can be culminated or fulfilled. So I request our regional director and chairman of the workshop, Shri Shrikant Manthanwar Sahab, to felicitate them with a small something, token of the love from the employees of Central Region. Shri A.K. Verma Sahab. Shri Ravindra Gurjar Sahab. Shri P.K. Gupta Sahab. Shri Shesha Rao Sir. Shri R.K. Jagdisha Sahab. I would request for a louder applause from the audience. Dr. Prakhar Kumar Sir. Dr. M.K. Roy Sir. Shri Rajiv Bidwai Sahab. It's the hard work of our seniors and their guidance, the fruit of which we are nurturing today, enjoying today. Shri N.K. Tiwari, sir. K.N. Tiwari. Shri Amit Majumdar, sir. Dr. Sachin Sahab. R.S. Yadav, sir. Shri P.K. Sharma, sir. Dr. Satyendra Upadhyay, sir. Shri V.K. Srivastav, sir. Shri Dhurandhar, sir. Thank you, sirs. As we move towards the concluding request, the convener of the workshop, Shri Rajiv Ranjan Sahab, to present the vote of thanks, which would be followed by the national.
Thank you, ma'am. Now we are about to come to the close of the first session in this very beautiful auditorium. So good morning to all. A sincere gratitude to all of you who have gathered at the workshop organized at the Central Region Nagpur, the workshop is being conducted on the occasion of Diamond Jubilee celebration of establishment of AMD, which is striving for the national cause on the mantra of exploration through innovation and atoms in the service of the nation. Today, in the same spirit, we are organizing the workshop on the theme Atomic and Critical Mineral Resources, Geological Insights from Central India, ACMR 2025. First and foremost, I would like to express my sincere gratitude to our director, the chief patron, and the chief guest of the day, Sri Dheeraj Pandey sir, additional director, the patron, and the guest of honor, Sri Prem Kumar Sharma sir, additional director, Sri Mayank Agarwal sir, Operation 1, additional director, R&D, Sri KL Mundra sir, without whose visionary leadership and continuous support, this event would not have been possible. I would like to express my sincere gratitude to Sri Neeraj Panda sir, head PMSG, for his dignified presence here, all the way he came from Hyderabad to this place. Many thanks to our regional director, Sri Srikant R. Manthanwar, who continuously and personally guided the entire process and led from the front to inspire the smooth execution of the entire program in a very short period of time. I also extend and thanks to all my distinguished dignitaries from the various and prestigious organizations of geological, mining, and exploration fraternity who are present amongst us. Your time and expertise are valuable to us. On this occasion, I would also like to express my gratitude to distinguished retired officers of AMD who have provided their precious services to this directorate. Additionally, I extend my gratitude to all the guests who have joined this program virtually at the far end and also to the esteemed dignitaries present in this auditorium. Your presence has adorned this event. Today is even more significant for AMD Central Region as it marks the inauguration of newly constructed Dr. D.N. Wadia Auditorium. In this regard, we are especially grateful to the CPWD who provided their invaluable supports in the constructions of this auditorium, and indeed it's a magnificent one. I extend my special thanks to Dr. M. Sridhar and all the officers and colleagues of the Engineering Services Group of the Central Region involved in the construction of this auditorium. I express sincere note of thanks to Srimati Sujata Mudliar ma'am and Sri Rajesh Singh sir from AMD headquarters who played a crucial role in the intensive planning and execution of the construction of this building. A special thanks also goes to invited speakers who offered their abstracts of their research paper for the abstract volume and will be delivering their talk in the upcoming sessions. The lectures presented by you will certainly enhance our knowledge. To make today's workshop and the inauguration of this auditorium successful, I extend my heartfelt gratitude to my colleagues who contributed to the editing, printing, and publishing of the abstract volume, and members of the various committees and subcommittees. Their hard work and the dedications are truly commendable. I also extend my gratitude to all the ladies who participated in the welcome song at the beginning and their sweet voice. Also thanks to the anchors who skillfully steering these proceedings. My sincere thanks is due to technical section, data center, drivers, security section, canteen, cosmetics, and support staff who played a significant role behind the scenes in the smooth running of this program. Finally, I thank all the individuals who were directly or indirectly involved making this program a success. This would not have been possible without your cooperation. Thanks to all once again. Now, my sincere request, all the ladies and gentlemen, to stand for the honor of national anthem.
I request everyone to please assemble outside the hall for a group photograph and then join us for a cup of tea. We would start the first session of the workshop. It comprises of 4 keynote lectures. Our first speaker is Shri Dheeraj Pandey, Director AMD. The topic of his lecture is Atomic and Critical Minerals Resource for India's Energy Security and Net Zero Ambition. Before I hand over the stage to Sir, I request Shri Preetam Karmakar to share his brief biodata to all.
Thank you, Madam. Namaskar. Sri Dheeraj Pandey is an outstanding scientist and eminent exploration geologist in Atomic Minerals Directorate for Exploration and Research, Department of Atomic Energy. He has more than 35 years of experience in exploration and research for uranium and other atomic minerals in various geological domains. He obtained MSc degree in geology from University of Lucknow, Uttar Pradesh in 1987 and joined the prestigious Department of Atomic Energy DAE as scientific officer in AMD at Hyderabad in December 1988. Since then, he has served in various capacities in regional centers at New Delhi, Jamshedpur, Jaipur, Bangalore, and headquarters Hyderabad. He has made noteworthy contributions in prospecting and development of Rohil uranium deposit in Rajasthan, Suramdi group of uranium deposits in Jharkhand, and Kanchankai Halkal uranium deposits in Karnataka. He has conferred with the Department of Atomic Energy Group Achievement Award 2016 in recognition of his immense contribution to the nuclear power program of India. He was also conferred with the National Geoscience Award 2019 by the Ministry of Mines, Government of India for his significant contribution in discovery and development of Rohil uranium deposit in Rajasthan. Sri Pandey visited advanced scientific institutes in Germany in 2013 as part of Advanced Techno Management Program for middle level scientists sponsored by Department of Science and Technology, DST. He has represented the Inter-Ministerial Government of India delegation and attended the participation in International Mining and Resources Conference IMARC 2024 and other related engagements at Sydney and Perth, Australia. As nominated representative of Department of Atomic Energy and member of International Atomic Energy Agency IAEA Uranium Group, he has attended the 60th Uranium Group meeting at IAEA Vienna, Austria in 2025. He has published more than 50 scientific articles in various journals and international journals and conferences. He is presently serving as the Honorable Director of Atomic Minerals Directorate for exploration and research. May I request Sri Dheeraj Pandey, the Honorable Director, AMD, to kindly own the stage and deliver a talk on atomic and critical minerals resource development, a cornerstone for India's energy security and net zero ambitions. May I request, sir, to own the stage.
Hello. Welcome back. Uh, so we begin this first session of the conference, and I would like to speak on some general aspects of critical and strategic minerals and how they can benefit our energy security and net zero ambitions. So let me begin with India's nuclear energy mission. The government of India, as you are aware, in this budget session, the government has promulgated this India's nuclear energy mission. And this nuclear energy mission for Viksit Bharat, it entails production of 100 gigawatt of nuclear energy by 2047. And why this is so? Because as you can see the quote by our Honorable Prime Minister, that civil nuclear energy will ensure a significant contribution to the country's development in future. So any development of a country, not only India, in future rather, it will depend on how we are harnessing the minerals. As you will see ahead, the importance of mineral sector to our future development, be it attaining a neutral carbon economy or for the purpose of energy security. So the whole story begins with the climate change. As you can see, the projection tells us that by year 2100, we will be almost doubling the atmospheric carbon dioxide levels since year 1800. And the fact that this is an alarming situation, it stems not from the fact that the climate change is occurring. Climate change occurs. Most of us are geoscientists. We know that ice ages recur after millions of years. There's a cycle going on. So there's nothing new. There will be periods of warm climate and cold climate. But the problem here is we are accelerating this climate change. So this is the main issue, how to reduce this pace. Now at the Conference of Parties in 26 in Glasgow 21, the Government of India has presented these 5 action plans. And the important ones are that India will get its non-fossil energy capacity to 500 gigawatts by 2030. India will meet 50% of its energy requirements till 2030 with renewable energy. And India will reduce the carbon intensity of an economy by 45% by 2030 over 2005 levels. And of course, we are trying to achieve net zero by 2070. So here the main focus is on renewable energy, as you can see. All over the world now countries are progressing towards non-fossil fuel sources. And each country has given itself a target of achieving net zero. The years may be different, but ultimately the world is going towards this net zero targets. So if you view India's cumulative power mix as on today, thermal power, it still dominates. Almost 50% of the installed capacity comes from thermal power, and 74.23% of the power generation is again by thermal source. So the importance of thermal still remains. We cannot just shut down the thermal power plants and replace them with nuclear power plants. Those are just theoretical facts, hypothesis that journalists may feed into your minds, but that is not a fact. thermal cannot be wiped out in a single instance. It has to play a major role in this net zero economy. Gradually, one has to replace those sources. Then renewable sources, you can see, although they are now 47% of the installed capacity, yet they contribute only 25% to the power generation. So that you see lots and lots of investment goes into this renewable energy sector, capital investment, but ultimately the output is not in consonance. And finally, the nuclear power, although at present it is just 1.85% of the installed capacity, it already contributes 3% to the power generation. So here comes the importance of nuclear power. It is a clean power, green power, and it has a huge potential as compared to even thermal. A small amount of installed capacity will generate a larger, comparatively a larger generation of power. And India, as you know, it is focusing on growth of renewable energy. From in the last decade, we have almost tripled our generation by installed capacity of renewable energy from 76 gigawatt. Now we have reached almost 230 gigawatt. Coming to the role of nuclear energy in energy transition, as I said, it's a clean energy, it's a green energy. Why? Because it has the least average life cycle CO2 emissions among other energy sources. You can see in this graph here, nuclear, it almost compares with the wind. And then it has the lowest land and structural materials requirements of all low carbon energy sources, whether it is solar or wind. You require huge amount of land infrastructure for solar panels, for wind turbines. But as compared to these low carbon sources, nuclear energy has the least structural requirements and the least land requirements. And nuclear power plants are the most reliable source of generating electricity 24/7. They can serve as your base load, and they work at any time of the year. It's not a seasonal variation which will hamper the production of nuclear energy. And they maintain the highest standards of safety, security, and emergency. Now, if you are to have a low carbon economy, at least 80% of mitigation efforts required by 2030 will be concentrated in the power sector. Leave alone the transport sector and other industries. And as of now, nuclear power can play a key role in meeting some of these pledges, climate pledges. At present, every third low carbon kilowatt hour generated in the world is nuclear. And every third kilowatt hour that is low carbon, it is giving us the carbon footprint of electricity generation. In 30 countries, you can see it is almost 90% below the global average. The countries which are using nuclear power as a main generation power mix, they have a carbon footprint of which is 19% lower than the global average. So this is how the India's nuclear power sector has grown over the years. From 1965, when we had the first reactors imported from the US, gradually the journey has been shown here. As on today, we have now around 8,780 megawatts of installed capacity. And this is the list of the reactors. Presently, 25 reactors in 7 locations in 6 states. The total installed capacity of around 8.8 gigawatt. And under construction, about 8 reactors of 6,800 megawatt, another upcoming 7,000 megawatts. So by 2031-32, we aim to generate about 20 gigawatt of power, up from 8.8 at present. Now we were talking about renewable energy and its role in net zero. There goes a saying that zero emission targets can be met by taking recourse to renewable energy alone, renewable sources alone. But for us, it is an ill-informed notion. I'll show you how. A study was conducted by MIT. If you see this graph, it's a complicated graph, but the overall conclusion that can be drawn from this graph is that if we try to achieve a low carbon, zero carbon economy based only on the renewables, various renewables, the cost of tariff, the power tariff goes very, very high. But if you have an optimal mix of renewables and nuclear, tariff comes down. So this shows that if you are to move to a net zero economy or a low carbon economy, if you do not apply this nuclear energy in that optical mix, the tariff will shoot up. And we don't want this. Low cost of electricity to end users is the key. So large scale contribution from nuclear power has to come. Besides the fact that base load can only be given by nuclear. You cannot run industries based solely on wind power or solar power or hydroelectric power. So the key here is to use an optimal mix of nuclear power with renewables. Now, if you see this is in the Indian context. In the last decade, solar power has grown tremendously, almost 28 times the installed capacity. And we added almost 13 gigawatt of solar power, the total power in first quarter of 25, and renewables accounted for almost 78% of this new capacity additions. And total non-fossil power capacity has reached almost 230 gigawatt, that is including nuclear. And solar and wind have crossed the milestones of 100 gigawatt and 50 gigawatt. And coal capacity recorded a net increase of 2843 megawatt during quarter one of this financial year, although coal's share in total installed capacity continued to decline at 46.7%. So there goes the saying that we are gradually now decreasing the thermal installed capacity and trying to replace that with renewables. But again, as I showed, that is not going to solve the problem. That is why the government, realizing this, has come up with a nuclear energy mission where there is a huge amount of importance given to nuclear power. Now, as I said, this energy transition, whether for net zero or for this low carbon economy or energy security, this will now require a huge amount of minerals. If you see this graph here, in the transport sector, if you use a conventional car, this is the amount of minerals that you require. But in an electric vehicle, see the amount of minerals that are required now. And currently, if you compare with 2020 scenario, sector-wise, if you see, we are going to have a rise of almost 4 times to 6 times of various sectors. And to implement this, we need certain minerals which are going to be used for this low carbon economy, whether it is a transport sector or electric power sector. Some of the minerals like lithium, they showed rise of almost 42 times as compared to 2020. In 2040, the demand for lithium will grow almost 40 times, graphite 25 times, cobalt 21 times, and so on. So the availability and affordability of these minerals is not sufficient for the world today. That is why the criticality comes in. That is why they are called critical minerals. And what are these critical minerals? Why some of these minerals that we are going to use in this energy transition, why are they so called critical minerals and what is their importance? See, this is a slide I use often, especially for my younger friends. Basically, critical minerals are economic drivers. They drive the economy of the country. Because if you have to expand your economy, if India has to become a $3 trillion economy, you will need these kinds of minerals to produce rare earth magnets, to produce electric vehicles. So these are basically the economic drivers. And as present, they do not have any substitutes. For example, lithium that you use in your lithium ion battery, it cannot be replaced. Although there are talks by Tesla that they are going to utilize sodium ion battery or aluminum ion battery. But as of now, the commercial production is not there. Lithium means lithium. Similarly, permanent magnets, RE magnets. There are no substitutes for RE magnets. That is why now the world is dependent on China. Then again, the existence, extraction and processing of these minerals is restricted to very few geographical locations in the world. Very few countries have the technology to process these minerals, let alone the resources. Resources are scattered around the world in pockets. And besides that, the processing technology is also available to very few countries. And because of that, there's always a risk of supply chain disruption because of this geological scarcity and the complex processing technology. To take the examples of rare earths, out of 110 million tons of rare earth oxide equivalent, that is the total resource, world resource, 94% of the resource are confined to only just 5 countries. So you can view that list: China, Vietnam, Brazil, Russia, and India at number 5. And of these, 40% are confined to China. And India holds just 6% of the world reserve to be in the rank 5. And when you come to the production, the processing, the production of the rare earths, this 97% production is just confined to 5 countries. And 68%, almost 68% is now controlled by China. And India, although it ranks number 5 in the resource, only below 1% is the production in India, which is, over the years, it has not increased nor decreased. It is just a plateau. So this is how the criticality of rare earth goes. And if you see the world map, you will see there are some clusters where you find these rare earth minerals. Come to lithium, 56% of the world resource is in 3 countries, the lithium triangle, that is Argentina, Chile, and Bolivia in South America. And 90% world's lithium production is confined to just 3 countries at present: Australia, China, and Chile. So this is the situation of lithium in the world as on today. And mind you, these are all controlled by geopolitics as well as economic factors. Lithium, for example, although the demand for lithium is growing year on year by 24%, but at present, compared to 2023, there is a downfall of almost 90% in lithium prices. Companies dealing with lithium, they are now going down. They are at almost at the point of bankruptcy. And we say that we need lithium for the world. So why this has happened? Because the projections of the industrialists, the world projections that EV industry will grow at a particular rate, that has not taken place. So the demand has certainly fallen for lithium, but that doesn't mean lithium is not critical. Critical elements in the Indian context. This study was carried out in 2016, and a risk matrix was drawn for the relative importance of some minerals in the Indian manufacturing sector. This is where the study started in 2016. And ultimately, India has come up with a list of critical minerals. Then coming to strategic minerals, these are again critical to the country. Of course, the difference being that they are essential commodities for nuclear defense and space, vital for national security. They may not be economic drivers as are critical minerals. And of course, there is a risk of supply chain disruption because of export restrictions. And although they are fairly available in the global market, the supply is again dependent on the geopolitical considerations. For example, India was not getting uranium from the outside world earlier. Subsequent to the signing of 123 agreement, the countries opened up. Some of the countries started exporting uranium to India. We started procuring uranium without signing the non-NPT. So these kinds of geopolitical scenario, they might change at any moment of the time. And that is how these strategic minerals become critical. And they also are part of the formulation of foreign policy. As I told, this 123 agreement with the US and all, this was basically done for procurement of these strategic minerals. Uranium, again, you can see 95% identified recoverable resource, just confined to 15 countries, and rest 5% is scattered in 24 countries. So this is how uranium also becomes strategic and as well as critical. I was talking about this list of critical minerals for India. So as the Ministry of Mines has notified 24 critical minerals in Part D of the first schedule of MMDR Act, and the blue ones that you see, these were initially part of the atomic minerals, which was later on modified, and these minerals were included in critical and strategic minerals list. Now, why these minerals are important for India, I need not stress upon it because I've already dwelt on this aspect. You know that these are foundations of modern technology. They can bring an energy revolution. And of course, as I said, they are drivers of economy. Future economy, if you really need that kind of growth in your economy, it will depend on minerals such as lithium, graphite, cobalt, titanium, and rare earths. And for some of these, India is 100% import dependent for some of these minerals. So that is why you need self-reliance. You need to achieve Atmanirbharta in these mineral sector if you are going to drive your economy forward. I think many of my colleagues will be talking about this, so I will not stress upon this, just for the fact that this National Critical Mineral Mission announced by the government, it basically it is looking for increasing the domestic critical mineral production besides acquisition of mines abroad. Coming to atomic minerals, which AMD deals. Now they are essential for the country's nuclear power program, for electricity generation and other strategic applications. And as I said, these atomic minerals are defined under the MMDR Act, and they are essential for the long-term security of the country, because if you have to drive your economy forward, you have to use nuclear power as your base load in future. This is the list of atomic minerals. Earlier there were 12 items. As I said, the top 6 have been removed, deleted from the list of atomic minerals by a notification dated August 23, and these were included in the list that I showed, the critical and strategic minerals. And the rest 6 now are part of the atomic minerals. Now, here lies a catch. Uranium does not figure either in the critical mineral list or strategic minerals. So does that mean for India, those minerals are not critical? Of course, these are critical and strategic, but the point is the list of critical and strategic minerals includes those minerals where private participation is open for mineral concessions. So that is why these uranium and thorium are not part of that list, because as of now, the government policy is that the nuclear industry is not open to the private sector. So that is the only reason why these minerals or elements are not included in that list. So this is how the progressive changes has occurred in AMD's exploration strategy. Today we have almost 428,000 tons of uranium resource. During the film, I was just watching our ex-director, Mr. Nanda, he was there. I could see a photograph where he was projecting to Dr. Jitendra Prasad. 2031, 32 projection was about 4 lakh tons. But we have already exceeded that target now, well before that year. And this has been possible because we have aligned ourselves with the world, the technological developments, especially using this conceptual modeling, mineral prospectivity mapping using IML and GIS. We've been carrying out multidisciplinary and integrated exploration. We are using high resolution heliborne geophysical survey as an aid. And we have embarked upon a program of deep drilling. At present, it is restricted to about 1200 meters, just because we don't have agencies, private agencies who can drill at a greater depth. But definitely we're going to increase this program. And we have state-of-the-art analytical facilities, and we are indigenously fabricating our instruments for radiometric surveys. So these are some of the points that have helped us to achieve this kind of resource augmentation. This is the present position. As I said, around 430,000 tons in 47 deposits in 6 uranium provinces of India. Some of these major uranium deposits are associated with critical minerals. My friend Mr. Panda, I think he's going to speak on that, so I'll not dwell on that. But only thing I would like to speak here is that a policy in the highest levels is being now formulated, is being finalized, where any major deposit, be it a base metal deposit or a critical mineral deposit, you need to explore and give the resource of each associated element with the major element, and subsequently that will also form the part of the mining plan. You cannot just mine the major element. You cannot just say I'll mine copper and leave around the other associated elements, maybe uranium or some other associated elements. Coming to rare earths, another critical mineral resource. AMD has been working. We have established this light rare earth deposit in Ambardugar, Gujarat, that is well known now, almost 1.1 million ton resource. It is now handed over to Gujarat Mineral Development Corporation Limited for mining. Similarly, in Sevana Ring Complex in Rajasthan, it is under active exploration. There are some 5 or 6 good prospects coming up. The good part is that it contains higher rare earth elements, heavy rare earth elements, to the tune of almost 30 to 40% of total rare earth content. And one of these deposits, the so-called Bhatikera deposit, is now going to come up in the next tranche of auction. So that will go to a private party for mining if the auction is successful. Similarly, we are exploring the beach places. As of now, we have established around 13 million tons of monazite. Monazite is a mineral of uranium, thorium, and rare earths. Presently, the entire rare earth industry in India is dependent on this monazite. As I showed you in the figure earlier also, the fifth rank of India, it is basically dependent on this figure. We are not considering the hard rock deposits of rare earths. So if you consider that, perhaps we'll have much more of this. And mind you, the grade of rare earths in monazite, if you compare it with the hard rocks, it is almost 10 times less. So that again is an important factor. Way forward critical minerals. I was just discussing with some of my colleagues. We often say India is deficient in rare earths, deficient in uranium, critical minerals, but that is, as for me at least, that is not the case. We have enough resources as of now, and we are continually augmenting that. Now agencies like GSI, MECL, they have also increased their participation in this sector. Problem lies in the midstream and the downstream. We do not have the technology to process these kinds of complex ores of, say, rare earths or lithium. That processing technology, again, as I showed you, is confined to very few countries. So there lies the problem. It is not the dearth of resources. If you're going to acquire mines in foreign countries, that will require huge amount of investment. And besides that, the prevailing geopolitical scenario, you have to consider the mining laws of that country. It will not be an easy task. But when the resources are available in your own country, we should be looking at them with a wider perspective. Why can't we develop a process technology by pooling resources? And of course, the downstream industry, again, midstream, this processing, and downstream industry also. Even if you process, even if you extract the rare earths, individual rare earths, you refine them, you produce metals out of it, you produce alloys, you produce rare earth magnets. Again, that downstream industry is lacking. Who will take the rare earths from you when the industry is not there? So there lies the critical problem of midstream and downstream industry. These are some of the milestones that I was talking about. Last 10 years, if you see, we have established 8 new uranium deposits in the country with a total tonnage of 40,000 tons. The uranium oxide resource augmentation during these last 10 years, it is 2 times the additional in total resource of the last 60 years. So this is at the rate at which AMD is working now using these modern technologies. Then the development of exploratory mine at Rohil uranium deposit is going on. Very soon it will become the first uranium mine in Rajasthan. First and the largest carbonatite hosted RE deposit. Mind you, it's a RE, niobium and thorium deposit. It's a multi-element deposit. And this has been, as I said, handed over to GMDC for this mining. And 2, this HRE Indus deposits hosted in alkali granite and rhyolitic tuff in Bhatiketa and Dantala in Shiva Learning Complex. They are, of course, the first and the largest of its kind so far discovered in India. So one of these, this Bhatiketa deposit, is now coming up for auction. And of course, lithium, if you talk of lithium, we have established the first lithium, although the resource is not much as of now, but the investigations are continuing. And probably we can speculate a resource of around 20 to 25,000 tons in this deposit. Then additional resource of economic heavy minerals, including monazite. And of course, the evaluation and development of significant uranium, lithium, and RE projects in various parts of the country. They are in advanced stages. So to conclude, as I said, to achieve Atmanirbharta in this critical mineral sector is very important for the country today. That is the dream of our Prime Minister. And we should all think in that direction, start pooling resources, not working in silos, whether it's exploration, whether it's mining, or whether it is processing or beneficiation. And of course, we need to adapt to these advanced geoscientific tools and digital technologies. Earlier, there was an emphasis on field work. Of course, geology is a field science and we need to work in the field. But of course, now we need to have an input of these digital technologies and other geoscientific softwares, which make the task much more easier and our confidence level also increases. But of course, as is well said, there is no substitute for field work. And with a strong geological base and policy momentum, India is now positioned to become a global leader in atomic and critical minerals, especially with the kind of focus for this collaboration with different countries like the Quad collaboration between India, Australia, US, and Japan, a close interaction between the Indian and Australian delegations. So all these things are coming up, and it is a good sign, a positive sign. And probably this is the way that we have to work together and gradually achieve a self-reliance in this kind of sector. So thank you all for listening. And any questions, I'm open to that.
Thank you, sir. Your talk highlighting the role of AMD as a scientific and strategic institution in the transformation of India's energy scenario. I now request Regional Director and Chairman of the workshop, Shri Shrikant Manthanwar Sahab, to felicitate the speaker, Director AMD, Shri Dheeraj Pandey Sahab, with a small memento. The memento is very special. It is having a beryl crystal. We now move on to the next keynote address. Lecture by Shri P.K. Sharma, Additional Director, Operations to AMD. The topic of his lecture is High Resolution Geophysical and Remote Sensing Data for Atomic Mineral Exploration in Central India, a retrospective and forward-looking perspective. Before I invite sir on the dais, I request Shri Preetam Karmakar to share his biodata.
Sri Prem Kumar Sharma, Joint Atomic Minerals Directorate for Exploration and Research. In 1908, after obtaining post-graduation from Humayun University, Nainital in 1980, he has a marathon innings spanning over 36 years in AMD, where he has contributed immensely in exploration and resource augmentation of atomic minerals in different geological domains throughout the length and breadth of India. He mainly contributed in the field of aerial survey and remote sensing in different parts of country, geological and geochemical exploration for uranium in Shillong Basin, Himalaya of northeastern region, NDFB Rajasthan, Chotanagpur Granite Gneiss Complex, CGGC, and Himalayas at northern region. He has served as Deputy Regional Director in Eastern Region, AMD, and as Regional Director, South Central Region. He has supervised and implemented uranium exploration in northern part of Kadapa Basin and contributed to effective functioning of laboratories and various allied sections of South Central Region. As Additional Director, Research and Development, guided the activity of beach sand and offshore group, rare metal and rare earths group, instrumentation group, physics group, chemistry group, mineralogy, petrology, and geochemistry group, human resource development, publication group, research and development training school at AMD headquarters. At present, he is Additional Director Operation with the responsibility of guiding the exploration activity of Northern Region, New Delhi, Central Region Nagpur and South Central Region Hyderabad, along with Airborne Survey and Remote Sensing Group, Exploration Geophysics Group, Atomic Minerals Data Center, and other allied groups. He has over 45 publications in various national and international journals and seminars to his credit. May I kindly request Sri Prem Kumar Sharma, Honorable Additional Director, Operation AMD, to kindly deliver a talk on high-resolution geophysical and remote sensing data for atomic mineral exploration in central India, a retrospective and forward-looking perspective. May I request him to kindly own the stage.
ठीक है मार्केट Good afternoon to all. My topic is high resolution geophysical and remote sensing data for atomic mineral exploration. Our director has already explained in detail the importance of the atomic minerals and the critical minerals, their present status, and the integrated approach for its exploration for the augmenting these resources which are necessary for the economic development and in our fulfilling the targets of these atomic minerals for the nuclear power program, which we are having target of 10 gigawatt by 2047, and the critical minerals importance has also been dealt in detail, and the exploration for them is necessary. As we all know that for mineral exploration, there are various geological settings, there are certain favorable criteria, and we have to go for exploration according to that. So initially we do as the field is the most important part of the exploration, but we have done the extensive field work and that will still go on, and every time field work is most important. But it is the time, and it is not the time because these airborne and spaceborne technologies are utilized since long back when the exploration started, and they were useful in the identifying the geological prospects and the extending the areas for the exploration and further augmenting the resources. But with the time, there have been changes in these airborne as well as spaceborne technologies, and the utilization of these technologies, especially for searching for the concealed deposits, it has become very important because superficial manifestation of the minerals are very less in the most of the places, and they are the indirect indicators we can for the even for concealed deposits we can identify by these remote sensing as well as the airborne data. So I will be telling the historical aspects what, because in worldwide these techniques are utilized and many mineral deposits have been discovered and extension areas were identified, and which turned out to be the very good mineral exploration targets next time. So these we will be, AMD has pioneered in this airborne as well as airborne surveys, especially because since the beginning, since the early 60s, we are doing the airborne surveys, and it has changed with the time, and now very advanced techniques are being used in airborne surveys. Similarly, in the spaceborne, the remote sensing has changed both in terms of spatial and spectral resolution, and data is very useful in exploring the mineral resources. So coming, why this airborne survey and remote sensing? We all know So just I will be telling the importance in the for this mineral exploration, but they are very fast, economical. Accessible areas can be covered, and large areas are covered. There is a resolution is very important aspect. It has changed with the time. Even the airborne survey earlier, we are using only airborne gamma ray spectrometry and the magnetic surveys. But now since 2004, this electromagnetic have been added, and it has helped indirectly very much for the mineral exploration, especially for uranium. Indirectly, we are using for it. Gamma ray spectrometry directly helps for the exploration of the uranium, potassium, as it gives the higher radioelemental concentration areas, which by the following the ground investigations, they can be explored further to turn into it, the deposits. So these are the methods which we use in the airborne surveys. They are the gamma ray spectrometry, electromagnetic, and the magnetic and gravity. And in remote sensing, earlier we used to, these aerial photographs were very much useful for the geological mapping, finding the structures, and identifying certain geomorphological features which help in the identifying the possible targets for uranium and other critical minerals, and extending from known to unknown areas. This hyperspectral remote sensing and this LIDAR, they are the latest which are included in the further remote sensing studies. Coming next. As far as uranium deposits are concerned, 15 types of uranium deposits I have identified, and with respect to India, uncontrolated vein type, sandstone and dolostone hosted, metamorphite and metasomatite. For these airborne geophysical surveys, they aid in identifying these concealed deposits, as I told in previous slide, directly by the gamma ray spectrometry and indirectly by interpreting this magnetic and the electromagnetic data by finding the structures which controls the mineralization and the sulfides, electromagnetic signatures, and sulfide, many places uranium is associated with that, identifying those features. So it is indirectly that we should keep in mind always, that all geophysical techniques are not a directly indicator, and indirectly, yes, they are the help in narrowing down the target areas. In the B sand deposits also, we can identify all the coast zone and in our structural features and the radioelemental distribution, which identified the higher radioactive concentration zones. In the rare metal, rare earth deposit, again this radiometric survey helps in the mapping the areas with the radioelemental signatures. And besides, many elements are associated with some intrusive bodies or the structures. Those things can be identified, and follow-up ground checking establishes those minerals. So these are just already I have told, they are the airborne geophysical surveys. They are high resolution data, and the multi-parameters like radiometric, magnetic, EM, they all are collected simultaneously. Even the inaccessible areas where we cannot go by go on ground, they can be covered by these airborne surveys. And I will tell one next, I will come. This I will say the development of this airborne geophysical survey systems by the AMD. Earlier days we were using the fixed wing airborne surveys. That was by Dakota aircraft. We are using the gamma ray spectrometric and magnetic surveys only, where data was received in the magnetic tapes and the analog forms. Here we are seeing the analog data, and at the base camp itself, we used to identify the radiometric anomalies and ground checking there and extending the areas for the having the higher concentration. Flight lines at the fixed intervals were plotted on topo sheets, and they were flown. So such data, and this is the system which was in use at that time, gamma ray spectrometer inside, and this red boom behind this, the magnetic tail. It used to be protoson precision magnetometer. The time changed, and we started using the electromagnetic surveys. Earlier, this system were using INS system, inertial navigation system, and after 2004, this GPS system was used for the navigation in the including electromagnetic surveys. And further, this in fixed wing also surveys were done in the 2007 by the for the electromagnetic. And further from 2008 till now, AMD is utilizing VTM electromagnetic system along with the radiometric and magnetic system. And the gravimeter also AMD has utilized in some of its surveys. And these development from the early 60s to till date have made this airborne survey data very much useful for the and integrating this data acquired from these surveys, integrating with remote sensing and ground data, identifying the many new areas for the exploration of the uranium and critical minerals. Yes, just I will be telling some features of this latest VTM system which we are using, the VTM transmitters, VTM receivers, and here magnetometer is also used in between, and this radiometric system, it is the crystal size is less here as compared to the fixed wing fixed wing surveys, as the height of the flying by this helicopter is less, 30 meter. There it used to be 120 meter, and the GPS navigation system and the radar altimeters are the making it more accurate and more precise for further interpretation. That is again AFMAG system that Geotech, in the name of JETTM, they have developed. It uses the natural electromagnetic field of the Earth, and that survey has also been utilized by AMD as by outsourcing, which is the passive EM system. These maps, resistivity variation are of great depth. Our VTM up to the 500-meter depth, electromagnetic data that conductors are collected, whether by the sulfides or some conducting formations like graphite, and that TM gives the conductor information up to the depth of the more than 1 kilometer. Now coming to the remote sensing data. No, sorry, this is the heliborne data. These areas we have covered by the airborne data. These major cratons of the country have been covered. Besides this, CGGC and this Arunachal Meghalaya, Naistic Complex and Gondwanas have been covered by this electromagnetic, magnetic and radiometric surveys. This is just to show that these areas previously only by the airborne survey and magnetic surveys we have covered by the fixed wing airborne surveys, and these are some blocks, identified blocks, small blocks, we have covered by the heliborne survey all over the country. So coming to the just what data this electromagnetic, magnetic and gamma ray spectrometry gives and what interpretation are derived from them. This electromagnetic data gives this many type of the images and the decay constant, conductivity depth, and we can do a 3 modeling. And these are the effective tools for to map the subsurface geology and conductivity. And the high EM response is due to maybe due to the conductors or the sulfides zones or shear zones, which are the favorable targets for the. This is very important data. And magnetic data very important for the detailed structural elements in the identifies the magnetic domain, basement configuration, etc. etc. Gamma ray spectrometry, as I told, it is the distribution of radio elements, which helps in making the geochemical map relation of uranium zones. and alteration zones and identifies the favorable targets for the ground follow-up. Coming to the remote sensing. Remote sensing is widely used since beginning, from the aerial photographs to the satellite data. Earlier, we were having Landsat IRS only, but it has developed a lot since last 40 years. It helps in the geological mapping and mineral exploration as well as resource management. AMD utilizes these data for getting the information like the lithological structural fabrics and marking the major structural zones, drainage analysis, sedimentary phases modeling, and digital elevation model. And in resource management, this data we are also using for the site selection, geotechnical investigations, mines and tailing pit management, and also getting the vegetation cover, environmental mapping, etc. These data we are using at present because these data are very good. They are having very good spatial resolution, even up to 0.25 meter resolution is there in the other data. And digital image processing helps in identifying the target zone by integrating all the data sets, including this remote sensing data as well as radiometric and other structural features derived from magnetic and EM data. These are some of the satellites which are having the resolution. We see here this Cartosat 3 is having resolution even up to 0.25% in the pen and 1 meter in the multispectral. So these all data, they are available to AMD, and we are utilizing this in our integrated approach for exploration of uranium and the other associated minerals which we are searching critical minerals. These are the spectral regions, what we can use for the different thematic mappings. So we all know this, but the spatial resolution and this their range is very important for the outcrop and mineral mapping and structural mapping, structural features that we all know. And even in site selection, we are using these all satellites. And the hyperspectral remote sensing, that is the most important target nowadays. Because each mineral is having an absorption band between the 2.3 and 2.36 micrometer interval. So this helps in mineral mapping and detecting soil properties like moisture, organic content, salinity, vegetation, crop mapping, and there are many other applications. And this data is very widely used in identifying the major minerals and even having the some mineral concentration in some areas. We are utilizing this hyperstructural data. This is the has already started unmanned this drone based hyperspectral remote sensing data. In this, effect of cloud can be mitigated and flying height is very low. And this is the data will further increase the resolution and the better integration with the other data sets for identifying, especially for the this successfully this calculate type of this type of deposits, and successfully this has been implemented for RE deposits in the arid climates as well as in the Finland areas. For coming to some case histories in central India where we have utilized this data. 2-3 case studies I will present because many studies will be presented by my colleague Sridhar later on the case Central India. In coming to Chota Nagpur granite gneissic complex, we see here that this is the airborne radiometric and magnetic data. It has this integration has delineated these pegmatoid leucosomes, which hosts the uranium mineralization in this area, and this data was integrated with the magnetic data we have obtained by the airborne surveys, and it has helped in mapping the different intrusive bodies, mahacausal sediments, and the different varieties of rocks within the CGC complex and identified the new target areas. We see in this central region part, these zones have been in Jaljalia, in the southeast of Sadbahani and Ucherua areas have been delineated, integrating all these magnetic, EM and radiometric data integrated with the satellite data interpretation. This is the base lithostructural map was prepared based on this magnetic, radiometric, electromagnetic data, as well as the interpreted satellite imagery of the high resolution. In the Central Sarguja shear zone, this discovery of this Dhabi anomaly is by the AGRS, and this Dhabi, Duat, and the Jajawal. They are the discovery and which were turned later on as uranium deposits. In the Satpura Gondwana basin, where these paleo channels are controlling the uranium mineralization, the delineation of these concealed paleo channels using the time domain electromagnetic data has helped in delineating these paleo channels, which are the host for the uranium mineralization. With these words, I will say that this multidisciplinary approach we are following for the mineral exploration, from the selection of an area to the preliminary satellite image interpretation, radiometric, magnetic image, time domain, and integrating all data sets for identifying the new areas for the further exploration, especially in the areas which are mostly soil covered, for the concealed type of the mineral exploration, and the digital integration is done using the different softwares. Thank you. Any question? Thank you then.
Thank you, sir, for sharing the advancement in exploration techniques and how AMD is employing the integrated approach for atomic mineral exploration. I now request Regional Director and Chairman of the Organizing Committee of the workshop to kindly honor the speaker, Additional Director Operations to AMD, P.K. Sharma Sahab, with a memento. Moving ahead, our next speaker for the keynote lecture is Shri P.K. Bhattacharjee, Controller of Mines, Indian Bureau of Mines. The topic of his lecture is Critical Minerals in the Rear View, a tale of tailings of Central India. Before I invite sir on the dais, I request Shri Preetam Karmakar to introduce sir to the audience.
Namaskar. Sri P.K. Bhattacharjee is presently working as Controller of Mines at Indian Bureau of Mines. He is a 1994 graduate in mining engineering from National Institute of Technology, Rourkela, with first class mine manager certificate. He has 30 years of diverse experience in the field of mining operations, mine planning, detailed feasibility study, technical due diligences, mine legislation, and regulatory framework, along with digital transformation while working in central government and public sector undertaking. Under his leadership, India Bureau of Mines has received the prestigious National Award in E-Governance from Department of Administrative Reforms and Public Grievances, Government of India for the year of 2024-25. Now, may I request the P.K. Bhattacharjee sir to kindly call upon the stage. His topic is critical minerals in the rear view, a tale of tailings of the central India. Sir, the dais is yours.
Good afternoon, everyone. I understand this is a team of eminent geoscientists, and what I think I am an odd man out probably. I am a mining engineer, but I have to my experience the design and development of lot many metalliferous deposits, and to name a few are some of the uranium deposits in the Yadugada belt. The first line I would like to say, while designing any mines, the first scenario comes the cutoff. At what cutoff my payload will be. And it's hats off to the Atomic Minerals Directorate and the Uranium Corporation of India to mine uranium at 200 ppm, which is basically considered as a waste worldwide. Topic that was given to me was a tale of tailings of central India, the critical minerals in review. As it has already been stated throughout, that critical minerals are those minerals which are having an economic importance, and at the same time they are having a supply risk. So these two parameters combined together indicates the criticality of the mineral. These critical minerals are also so-called critical because of their unique catalytical, metallurgical, nuclear, electrical, magnetic, and luminescent properties. Now, the Mines and Minerals Amendment Act was brought about in 2023, listed 23 such minerals as the critical and strategic minerals. And these are the minerals that has been listed in the Part D of the first schedule of the MMDR Act. Now, what is the issue in assessing these critical minerals? We need new mining ventures. We need to establish technology to recover these minerals as a byproducts from the existing mines. We need the same to recover the same from the long, big waste dumps present in the existing leases. And ultimately the concept of recycling to reuse these minerals. Now, what are the available upstream exploration and extraction facilities that here are existing? We do not have any working mining leases for cobalt, nickel, production purpose. These are all those minerals which I am telling which forms under the purview of Bureau of Mines. majority of the critical mineral explorations in India are greenfield, and the challenges ahead are the deep-seated deposits, high risk of advancement, and the advanced mining technology and beneficiation techniques that needs to be deployed. In the course, when the need arises, and so as everybody has awakened, we have taken somewhere around 3,500 samples, different deposits from the mine faces, from the existing waste dumps, from the processing plants, from the tailing ponds, and we have tried to assess what is the potential that we are having at present to recover anything from the existing tails or whatever be the waste we call it today present in the mines. And the right side shown is the typical mining process. Starts from mining, the beneficiations, wherein the rock dump is classified, the ore mined, as well as the subgrade, the middling, and then during the processing, the different products that are being created and the waste that is being dumped and the metal that is being generated. Now, why tailings? How tailings comes to a prospect for us? Because we find that it is close to a liberation stage. It will require much less of investment if we can deploy a technology so that we can exploit or bring about or evolve a good mineral from these tails. In this, the case study we have taken is the Malajkhand mine. It is one of the largest open cast copper mine that is present in the central India, located in Baladhar district of Madhya Pradesh, and is a porphyric copper deposits, a very low grade copper deposit. Tonnage is quite high. Approximate reserves is somewhere around 300 million. And this quantity or this reserves is further expected to grow further. And there are large quantity of has been generated and stored in the tailing pond, as well as being parallelly used for the flowing purpose. This is the pictorial presentation of the Malajkhand tailing pond. It is spread about an area of somewhere around 250 hectares. It is close to the size of a lease that one is having. And it is having a deposition of somewhere around 80 million tons of tails in it. We have taken some samples and have done the radical analysis both for the tails as well as for the waste dumps that are available in it. In this, we have categorized, we have taken 4 samples from the tailing pond of Malajkhand. We have tried to analyze the base metals, the RE content, and the strategic minerals. Here I am just plotting respect of the base metals, the 4 samples and their concentration. The y-axis indicates the sample and the x-axis indicates the parameters that is being measured, and the right side graph you can see that is indicating the concentration. In general, what I find that the base metals, that concentration of the base metals is not very attractive in the tails. Now this is in respect of the heat map distribution or the statistical information available for all the samples in respect of the REs. Here also you can see the maximum concentration of 35 ppm. If we add upon all the REs together, that also it will be somewhere around 150 ppm. So it doesn't proves to be very prospective. These are the heat map distributions in respect of strategic metals. And here you can see the peak concentration of 250, but some small prospects of molybdenum is there. You can see somewhere around 30-34 ppm, although it is there. That too, it doesn't seems to be very prospective to be extracted at this stage with the technology available. Now, when we have taken 7 samples from the waste dumps that are available in this mine and analyzed the same parameters in respect of all the base metals, REs, and the strategic minerals, this is the heat map that you can see. Here also you can see the maximum concentration of 100 ppm, and that too doesn't seems to be a very good prospect. The REs is a similar case, what we saw in the tails. The sum total of all the RE concentrations, even if you take it, is somewhere around 150 to 200 ppm. It's not a big deal. But in case of strategic metals, you can see the concentration to an extent in for tin. There we have found somewhere around 160 ppm of tin and around 50 to 60 of cobalt. Oh, sorry, molybdenum. So there we have seen an anomaly, that there is an anomaly existing and we have to trace this anomaly. So this is the outcome that we have seen for the tails. The base metals, in respect of the base metals, these are trace levels only, and we rate it as a poor. In terms of the REs, the likely concentration is around 150 to 200 ppm, the marginal range. And the strategic metals, we have found some molybdenum, but still it is an outlier and it is in low. But for the waste dumps, you can see the same trend in respect of the base metals and RE. But for strategic metals, we have seen an anomaly for tin-rich sample and a bit molybdenum-rich sample, which are notable. So the way forward, we are on the process to do follow-up sampling on the anomalies of tin and molybdenum zones, so that be economically interesting if we find the localized enrichment of the same. That's what we have done a little bit of investigations in respect of the tailings presence in copper in central India. Thank you. Sir, as you know that in the earlier Rakha belt, where the earlier processing plant was working, and there was also a uranium recovery plant installed inside the Rakha premises, there also molybdenum was recovered. But as of now, we are trying to establish the threshold cutoffs in respect of all these critical minerals after establishing a thorough study of this.
Because that kind of study, if it is available, then it can be shared among all the.
Yes. Yes.
That we can have, once we have, because when we are also collecting this kind of data. But because as of now, we are not aware of what particular cutoff we should think that this is going to be economically viable to extract. Like, for example, we are talking about extracting molybdenum or uranium from copper tailings. Uranium is such a strategic element, as you said, we are working in such low cutoffs. So it has to be mined whatever the cutoff. We have to do it. So there the economics doesn't work. But for other critical elements, probably we have to see the economy also.
But in all organizations, there are concentric organizations. Some importance has to be taken to consideration for that. But very soon we also will be evolving a cutoff for this.
I just want to know, has such a study been done for the tailings of sporadic thermal power station? You know, I'm very specific about it, and I'm sure that you would find something very interesting in that. Number one. And number two, the second part of my question is that having stayed very long in Meghalaya, especially in the Mahadex where we worked very extensively, I just want to know how much is the involvement of IBM now in Meghalaya? Because there was a time when it was not, I mean, they were not allowed inside.
Actually, IBM deals major minerals, include atomic and hydrocarbon energy minerals. So the samples that you are talking for the Kuradi plant and Meghalaya for the entire 8-7, we are having an office at Guwahati.
Okay.
We are having an office, but that too is on this minerals which are intended for IBM.
For this fly ash of Koradi, I'm not very specific about finding uranium in that. You would find certain minerals in that which is of your interest.
Yeah, that's
sure.
true, sir. But the power to entry and access for such
I know, I do understand, but you must be having an access to those sectors. No, you don't have an access.
We do not have access, but let me explore. There is some.
Please do
possibility
find
of-
out, because we would also be enlightened by your findings in the ash of Koradi Thermal Power Station. Because the coal comes from either Silevara or from nearby area. Sauner, mostly Sauner, yes. So it'll be very interesting. Thank you. Thank you very much.
Sir, just can you tell me the tailing sampling, that samples, it represents up to what depth?
Sir, actually, this is an old tailing pond. See, the embankment itself has been created with the depositation or the siltation of.
Yeah, that's what I'm asking. Just is it representative of some thickness, or it is just a surface?
It has been taken from a thickness.
Okay. What is the thickness, sir?
Somewhere the top 3-4 meters we have taken.
Okay, thank you, sir.
Sir, for your good information, this Khaparkheda and this another dumps from the power plant, it is now freely available for the people. They can, even the fly ash makers and bricks makers, they can take it free of cost. So I think you can generate your sample.
Thank you for the information shared. I would like to know the study which you have conducted, the time and the cost. What is the thing?
Very preliminary study. We have just started. We have collected the samples. Even we have not got the results of the entire 3,500 samples. So we are in the process, just started, just mobilizing the things to arrive at certain potential areas which can be further promised.
Sir, I would like to know, one of the slides you have shown that you have analyzed many samples. Have you analyzed Indian laterites for nickel?
That is there, but actually this context was for the central India, that the overburden terms of the Sukinda belt and all. So
No.
there is a different section of the working on it. So
particularly nickeliferous laterites have not been
the
reported
Sukinda
in
belt,
India.
we have collected many samples from the many around 5-6 leases existing in the Sukinda belt.
And second thing, I have assessed one of the fly ash coming out from the 7-star steel in Odisha. It has got very anomalous value of germanium and gallium. I wanted to get it metallurgical test done in Indian IMMT, now they call it Bhubaneswar. So, but they said that 15 years they have been trying, but they could not extract. But the same level, Chinese are extracting gallium and germanium, both of them. Thank you. So I would like to suggest that IBM should look for the Indian laterites for nickel, because I have established one nickel deposit in Uganda, 60 million tons in laterites. So that will be the first nickel deposit in Uganda. So in India also we have got a lot of laterites which have been derived from the basalts, means Deccan basalt, and it can have nickel in that.
Surely there is having a reliable good concentration in the forward enzymes. That's what I stated. We have collected the samples, but on the process.
जब क्वेश्चन आएगा नीचे आएगा बंद करो।
Sir, for informative talk highlighting in entire mining to metal value chain involving an entire array of critical minerals. I now request Regional Director and Chairman of the workshop, Shri Shrikant Manthanwar Sahab, to present a memento to our speaker, Shri P.K. Bhattacharya.
हाँ बैठ जाऊँ सर उधर बैठो वहाँ दिक्कत आ जाए अभी सर मैडम एड्रेस करेंगे ना उनके बाद जाऊँ
Moving on to the final keynote address of this first session. The speaker is the Dinesh Ganvi, Additional Director General, GSI Central Region. The topic of Sir's lecture is Unlocking Critical Mineral Resources of Central India. I once again request Shri Preetam Karmakar to read out the biodata.
Namaskar. Sri Dinesh Vittal Rao Ganvir has joined Geological Survey of India in 1994 as Geologist Junior and presently working as Additional Director General and Head of Department and National Mission Head to Geological Survey of India, Central Region, Nagpur. During his career, he has worked in the organization, delivering not only in the technical field but also had held positions for handling the finance and administration of GSI Central Region. He was extensively engaged in the basic geological mapping and mineral exploration programs of GSI, like Specialized Thematic Mapping (STM) in Western Buster Craton, Chandrapur, Gadchiroli district, Maharashtra. Mineral investigations programs for precious commodities like gold and diamond were carried out in Sakoli Fold Belt, Chandrapur, Gadchiroli, and Nanded district of Maharashtra. The most challenging was the geoscientific studies of UNESCO World Heritage Site of rock shelters around Bhimbetka and Bhaiyapur areas, Raisen district, Madhya Pradesh, and for conservation of Flora Caves, Aurangabad district, Maharashtra. As Director of Earthquake Division, Central Region, Nagpur, supervised field programs of seismic hazard microzonation study in Koyna, Varna area of Satara district, Maharashtra, and in Indore. Presently, D.V. Ganvir is holding the charge of Additional Director General and HOD Central Region, Nagpur. He is engaged with the planning, monitoring, and execution of almost 449 exploration investigations throughout India, being further executed by central, western, northern, eastern, northeastern, and southern region. May I request Sir Sri Dinesh V. Ganbir to kindly come on the stage and deliver a talk on unlocking critical mineral resources of central India. Please, sir, the stage is yours.
Hello. Thank you. Good afternoon, all. I'm Dinesh Ganvir, Additional Director General from GSI. A great audience of scientists, academia, and the backbone of any organization, the retired strength, which I am seeing in front of me. Thank you. Thank you, Manthanwar Sahab, for giving me the opportunity to have a talk or interactive discussions with the officers of AMD. Thank you. In my presentation, I will be just briefing about the areas, the mineral belts, focusing mostly the central India, covering the Maharashtra, MP, Chhattisgarh, with the exploration activities being carried out by GSI and especially the critical mineral projects and its outcome. So seeing this geological map, you can see we do have the Archean cratonic nucleus, then the deformed TTG, and 1 minute. So coming to the Kotri Dongargarh and the Sakolis, here we can see this is the Kotri Dongargarh sequence. We do have the granites. This is the Dongargarh granite, and here you have the Bundelkhand granites and the Malachkhand granite. And coming to the Proterozoic sequence of Mahakaushal, Bijawar, Gwalior groups, Betul, Bilaspur, Raikar belt and Sausar group. Here we have the Sausar group and here we have the Mahakaushal belt. Coming to Meso-Neoproterozoic cover sediments, the Vindhyans, the Chhattisgarhs. So you can see the Vindhyans here, Vindhyans and the Gondwanas. That is the Paleomesozoic Gondwana supergroup. And rest is the covered the Deccan traps. So from the geological map pertaining to these three states, we can see the most potential belts which lie in the part of the Madhya Pradesh as well as Chhattisgarh. So this is the mineral potentiality pertaining to these three states. In Chhattisgarh, if we see the Bastar, Malkangiri pegmatites for niobium, tantalum, beryllium, and tin, potash, phosphorite, and limestone belt in Chhattisgarh basin. Then Sarguja uranium belt for RERM pegmatites in western Chota Nagpur granitic gneissic complex CGC, and South Raipur Bastar kimberlite belt, and Dalli Rajara for iron belt. If you go for Maharashtra, we do have the Pular Parsori Kolar, that is the Thanu Yasna Goat Chamorshi zinc belt. Then for manganese and pegmatites, RE is the Sausa belt, and bauxite and associated critical minerals in the western part of this Maharashtra. Then the Agargaon Kuik Hobna tungsten belt. Coming to Madhya Pradesh, we have the Malachkhand copper belt, the gold mineralization in Mahakoshal belt, zinc copper lead sulfide mineralization of Betul belt, graphite in Betul belt, and Jhabua Hairpur Sonrai phosphorite belt, diamonds in Panna belt, and the bauxite belt of Madhya Pradesh. Coming to these mineral belts, going for exploration, how do we work out for any potentiality of that area, right from taking of the investigations, as per MEMC, right from the G4 stage investigations, and carrying forward up to G2 stage. So for that, we need to have a base where for which commodity we should carry out the exploration. What GSI has done, though since its inception, we are carrying out the exploration activities, but we had worked out in 2020 the obvious geological potential areas for 18 commodities. So that in 2020, the database, it was 6.88 lakh square kilometer, which since then GSI is being taking its exploration programs. Coming to the central part of India, that is the central region. This is for the 16 commodities, what's commodity-wise I had given here. For Maharashtra, that is 44,251 square kilometer. For Madhya Pradesh, 11,000, 1,14,000, and Chhattisgarh, it is 16,000. I would like to put up that, submit that the OGP area, which needs the revision, since the database is of 2020, right now for this 25-26, we have taken the programs to revisit the OGP. Every 3 to 5 years, the OGP needs to be revisited. Though GSI, since after 2020, they are carrying out their exploration programs in the extended OGP areas, and the database, we are going to see that the revised OGP area is there to carry out further investigations. This is the OGP as the commodity wise for Madhya Pradesh, Chhattisgarh, and Maharashtra. What earlier I had given the figure, that is with respect to the commodities, 16 commodities. In total in 2020, for rest overall India, we had taken for 18 commodities, out of which 16 we had taken for this 3 states. Now, since GSI, right from 2021, we were supposed taking exploration programs under mission 2. We are working under mission mode right now. It was around 160 to 170 number of investigations under mission 2. But with the thrust to go more and more having exploration programs, right now in this FS, we had taken almost 449 exploration programs, and that to a major thrust on critical minerals. Critical minerals in the sense, I, as a member of this committee, we were involved under the aegis of able leadership of Ministry of Mines to identify the critical minerals. Things were there. It was not key, we were not having the critical minerals identified in India, but that it was with certain agencies like CEW, CE, then CTEMPO, CSEP, IDSA. Agencies likewise having the empirical formulas, they had identified these critical minerals. But government of India thought, no, for India there should be a critical minerals identified, listed, for which they had some plan to take forward. So this committee had identified the critical minerals. So it was a major task taken by the team involved. Not only the interministerial consultations with all these 6-7 ministries were headed by a Ministry of Mines, but the reports earlier submitted by the CEE, CW, then IDSA and other agencies, those were studied. Then the countries which are much more efficient in exploration and exporting of critical minerals like Australia, UK, USA, we had seen their reports. We had studied their reports, how they had gone for the identification of critical minerals and how do they revisit. It differs country to country. So this was a major task, and one of the major tasks where IBM has helped in this task, that we do have the import-export data, that is the NMI database. We had got the NMI database from IBM, and we had tried to understood which are the commodities we import, which are the commodities we export, where we are dependent. That was the major database from NMI we had considered for taking up this critical minerals identification. So in August 9, 2023, these are the critical minerals identified. Now, coming to the exploration activities taken by GSI, in this regard, if you come to this first one, you can see what I told. That was for the total exploration projects. What I told, right from 170, we had taken up to 400 and odd figures of exploration. But focusing to the critical minerals, if you see, right in 2021, there were 20, now it is 61, 20 by 26. Almost 3 times we had put the thrust to take these critical mineral investigations from GSI. They are from, you can see for these 3 state-wise. So if you see, here it is 8, now it is 14. And same thing, what I think this audience knows, how we take the exploration programs, how we, under which stages, what activities we do carry, right from G4 taking to G3 and then G2, that is right from CL to ML. So the very base of any exploration, taking it up to identification of resource, that is the G4 stage investigation. Here you can see in G4 stage, this is the FS 21, 22 to 25, 26. You can see the 16, it is almost doubled in 32 in FS 25, 26. Same is the case of commodity. In commodity, if you see, much more focus, we are getting the REs than the bauxite. We are having this glauconite and graphite. One thing, there was a question regarding the laterite, the nickelferous laterites. One of the audience, from the audience, they're told about having some reserves or resources in Uganda. We are taking projects along the west coast of Maharashtra. We do have a RP project right from along the whole of the west coast. And along the during the course of RP project, we had studied the lateritic sections. Lateritic sections in the sense, at the top part, at the 1 or 2 meters of the Dewey crust, we are getting the values of vanadium and gallium, and that too more than 1000 ppm. And about the nickel, just the W5 grade weathered rock, above the hard rock, there we are getting the values of nickel around 300 to 400 ppm. So almost we are taking number of programs all along the west coast. Our focus now is diverted from bauxite or aluminous laterite to critical minerals, since we are getting the values of vanadium for more than 1000 ppm, and even in the lower part of that section we are getting the nickel values. So a number of programs we are taking, and we are working out for more blocks towards critical minerals. Now, what I told about the taking of the exploration programs, but taking investigations, what is the outcome? What is the outcome? What is the deliverance to the nation from GSI? So you can see the G2, G3 stage GRs. What happens every year, we are taking up the programs, we are generating the reports at every stage. And as a potential auctionable block, we are handing over to the state governments to Ministry of Mines in the mining conclaves, held by the Ministry of Mines during several organizations, twice in a year or once in a year. So these are the geological reports. I'm just telling about the critical minerals. Overall, if I want, the figure is 568. We till date, GS has handed over throughout blocks the geological reports and the geological memorandums. They are 568 and 34 another exploration license blocks. From those, after identification of critical minerals, since earlier these blocks were being given to the state governments, but auctioning was much focused on the iron, manganese, and those commodities, and less focused with the critical minerals. where government of India thought why we should not work on the less dependency by generation of resources in turn the reserves. That was a major thrust given on critical minerals, from which till date, out of 161 critical mineral reports, 54 had been put up for auction in several tranches. I will come in my presentation. In several tranches, 5 tranches had been completed, and almost auctioned figure is of 34 number. This is the geological memorandum for critical minerals, that is 78. What I told the figure of 161. So this is for the commodities right from cobalt up to titanium, and you can see the states. You can see the Chhattisgarh for geological memorandums, Madhya Pradesh and Maharashtra. Almost more than 30. For geological reports, you can see almost in 10 and 18 reports submitted. We'll come to the auction figure also. So from Chhattisgarh, total the blocks handed over are 8 as reports, GRs, auctionable reports, and the geological memorandums, they are 10. For Maharashtra, report 3, CL as a GM 5. This is for Madhya Pradesh, report 7, and GMs are 19. These are the several tranches during which we have taken the certain blocks worked out from different states, almost 15 to 18 states pertaining to the critical minerals identified for India, and put it for auction. So almost till date, 54 blocks in several tranches had been put for auction. And what is the outcome? These are the tranche 1, tranche 2, tranche 3, right from 2024. Joint Secretary Designated Officer, Ministry of Mines, is heading this auction, where GSI and MECL, they are working on the auction process to the Ministry of Mines, where MSTC and SBI caps, they are the transaction advisors. So these are the total auction blocks. You can see potash 2, most of phosphorite blocks, then you have the graphite and vanadium, and the blocks which are auctioned till date. Almost this figure needs to be updated since it is coming to 34, because 4 from MECL, 1 from I think DGM Jharkhand, and rest 28 from GSI. These are the blocks auctioned till date. These are the details about the blocks from Chhattisgarh. This Auranga Revtipur, then Raipura, you have Samardi, Katgora for lithium. Then for Madhya Pradesh, for graphite, phosphorite, Holighat, Bahira Goriara, Surajpur, Patali Choti. And from Maharashtra, Vadakala Soli. Not only the critical minerals, identification of critical minerals giving a thrust to boost up exploration activities. Ministry of Mines had amended in August 929 the 7 scheduled minerals for which the exploration license was supposed to be given, where the area was restricted to 1000 square kilometer max to anyone 5000 square kilometers. When regional scale, the exploration activities, including drilling and pitting, are allowed. So that was the major amendment, where GSI was asked to prepare and give those blocks to Ministry of Mines, to state government, in the sense to Ministry of Mines for auction. But afterwards, the Ministry of Mines, they had taken into their we will do it for the auction. And in turn, last January, we had handed over 34 exploration license blocks with almost 200 square kilometer of area, which in Tranche 1, Ministry of Mines has launched for auction. So this is the total of 34 exploration license blocks, which GSI through the various states, right from Andhra Pradesh up to West Bengal. The number you can see. We had prepared these EL blocks for exploration activities throughout the India. And these are the in Tranche 1, the total 13 blocks, which has been launched for auction by Ministry of Mines. The way forward. Already we do have the 6.88 lakh square kilometer. We are left with 1.5 lakh square kilometer, and we are working with the OGPs. And I think by next year we will be having extended OGP areas, the trust where we need to have the exploration activities. But that is not the OGP now. Since we are carrying out the NGPM, the NAGMP studies, now is the time, the surface we had almost covered for exploration activities. Now we have to see deep inside the crust to understand the mineral potentiality, the mineral system from known to unknown, and have the more and more projects to identify the deep concealed projects where the other countries like Australia, UK, China, and Japan, they had carried out almost the magnetotelluric survey of their countries, the DSRS. They had tried to understand the deep fracture system, the mineral system, and they had been successful in identifying the resources, in turn converting it to the reserves. And since they are governing in these critical minerals, that is one thing. Then potentiality check below the thick proterozoic basins. What I told the MT and the DS with the help of our DSRS surveys, as well as we have the passive seismic survey that can also be taken. Then AIML, as at every organization now using, we are already each and every organization, including GSI, DGMs, AMD, we are uploading our reports, the exploration reports in NGDR portal. We can have the mineral productivity map. We can have the mineral productivity map, and accordingly, we do take the investigations. But the better understanding using the algorithms, having the artificial intelligence, working out the systems where we can have approach for the new commodities in the sense for critical minerals. So that is thing. Now the last two, as we know, are not only a GSI, they are carrying out these exploration activities, generating number of potential reports, handing it over to the states or taking it for auction. But there are projects with collaborative projects where in the southern part with Russia, AMD is there in collaboration. We had taken that project under with Russia under Rosgeo for REs, and we do have the TOR terms of reference with Geoscience Australia, where our last 6-7 years we are working with Geoscience Australia in the transects. That is the northern transect been taken in Rajasthan and Madhya Pradesh, then southern transect Andhra Pradesh, and in the eastern transect, where in the critical minerals they are helping, guiding rather Geological Survey of India teams to take way forward to understand the deep-seated concealed minerals from known to unknown. So thank you all. Thank you. If any queries, questions, please. Thank you. Hmm.
Thank you, sir. Considered to be one of the oldest and biggest exploration institutes in India, it was really heartening that how new technologies are being put to use in GS for mineral resources. I now request Regional Director and Chairman of the top organizing committee to kindly honor the speaker, Shri Dinesh V. Ganveer, Additional Director General, GSI Central Region. Thank you, sirs. We come to an end of the first session, and it's time for lunch. We would break now. And keeping in mind the schedule, I would request everybody to reassemble in the hall in about 25 minutes.
बात तो सही है बस ये लगता है कि सिस्टम हमें नहीं ज्वाइन सिस्टम नहीं चाहिए नेक्स्ट नहीं इसमें मेरे काफी
बढ़ी गया नंबर
बढ़ी जाएंगे फिर इसमें क्या दिक्कत
कंटिन्यूस इसमें देखने से जो काम करना है तो मेरे को एक डेस्कटॉप ऐसे दे दो जो लिंक कर लूँ मेरे पास तो था ही ना, दे दो इसको वापस दे दो। हाँ इसमें मजा नहीं आता। हेलो सर, गुड आफ्टरनून सर। सर है टू बाबूलाल कुमार बोल रहा हूँ सर, एसी का कुमार। ये क्लास 8 में है एसी का कुमार। तो उसका नाम में क्या इश्यू हो सकती कि उसके जो बर्थ सर्टिफिकेट है वो इसी का है और प्रदीप सर। चलो ठीक है, वो क्लास टीचर मैडम ने उनको बोला जीतू सर से बात। पुराना तो अभी क्या कैसे से चेंज वो कर पा नहीं पाएंगे सर, वहाँ पे कौन जाएगा छत्तीसगढ़। प्रदीप सर से ना, ठीक सर ठीक।
अनम्यूट है मेरे पास, मेरे पास नहीं आ रहा यार आवाज।
बोल रहा है कि जीतू सर तो बोला प्रदीप सर से मिलना।
Seventeen 20 project in pan India, and we have added around 220 mineral billion tons resources to the national mineral inventory. These are our you can see in the map. These are the present locations of our running project. Presently, we are running about our 71 project under NMET is in progress. So these are and we are doing exploration in the border area also, in Jammu and Kashmir, in Gujarat, Kutch, Rajasthan, and in Arunachal Pradesh. So to meet the northeastern and tough terrain area also, MECL also actively participating in the exploration campaign in the northeastern area also. So this as on date and after the formation of NMET, as on date MECL has taken 226 NMET projects. And out of it, 72 projects are of critical minerals. And in central India, we are having 22 projects. 14 projects are completed and 8 projects are in progress. 2 projects in Maharashtra, that is of tungsten, that is Kui Kobna, that is area between Kui Kobna, and one vanadiferous magnetic project in the Malda project, that is in the Bandara district. So these 2 projects we are exploring for the mineral Maharashtra, and another 2 projects in Chhattisgarh, one for tin and another for gluconite in Chhattisgarh basin, and another 8 projects in Madhya Pradesh, that is of tungsten, RE, and for lithium, and we are doing some lot of project in the bauxite. In Madhya Pradesh, we are getting anomalous values of this titanium, vanadium, and gallium in the bauxite zones. So that will be coming covered in our next presentations. And this MECL also doing the, as Ganveer sir already told, MECL is giving these technical support to Ministry of Mines for auctioning the critical minerals. As on date, 54 projects has been auctioned in the 5th tranches, and out of it 34 projects are auctioned so far, and 5 projects are of belonging to the central India of MECL. So these are the some challenges challenges in the exploration. Exploration sensitive terrain, balancing the resource development with ecological and social responsibility require careful planning and execution. Limited processing ecosystem, inadequate downstream facility hinder the refining the value addition of critical mineral, necessitating new infrastructure. Data and infrastructure gap. There is a pressing need for integrated geological data system and modern logistic support in remote exploration areas. Then integrated approval and land accesses, streamline the permission, because you can know that there are a lot of delay in execution of the project after auctioning it. So there is some timeline should be fixed for the obtaining the EC clearances and land acquisition. So which accelerate the project operations and we can get the critical mineral for our need purpose. Next is public-private research collaboration, leveraging combined strength for technology development and field execution and capacity building is essential. This is very much essential for private-public collaboration in the difficult areas. Now the Ministry of Mines are accredited around 33 exploration agencies to enhance the exploration, as well as this private exploration agency can take up the project in the difficult and law and order areas, because now in the Maharashtra and the Gadchiroli area, now they are explored 5-6 blocks by the private exploration agency and they are in auction platform. Like that in Chhattisgarh, we are having the critical mineral depots prospect in the Bastar area, that is a tin, lithium, niobium, all these are underexplored due to this law and order problem. So there we can have this public-private collaboration to tap the critical mineral in those areas. So this investment in processing infrastructure, yes, the developing the pilot and commercial scale facilities for strategic mineral is crucial for value addition and self-reliance. So this is the innovation and collaboration to drive exploration excellence. In geologically complex and environmentally sensitive regions in central, that I already told about the sensitive area like Bastar and the Gadchiroli in that area. This critical mineral exploration requires a balanced innovation-led approach to build 3 key pillars. That is strategic partnership, collaborate across border and sectors engaging international exports. Then research institution and industry players to develop an integrated value chain from resource discovery to processing. Then the technology-enabled exploration. Leverage cutting-edge technologies, because we are using modern technology nowadays. Actually, MECL is doing this that advanced technology, that is geophysical techniques like this magnetic telluric, time domain, electron domains, and we are procuring the 2D, 3D seismic to develop our deep seismic reflection studies to discover the critical mineral present in the deep-seated areas. So such cutting-edge technologies coupled with a data-driven decision system enable precise and efficient and low risk exploration method. Also adapt low impact exploration techniques, because now we are discussing about lot of discussion on the extraction of critical minerals. So you know that the world famous lithium is available in the lithium triangle. It is in salars. So the main risk factor is that water scarcity. So one should develop the R&D and eco-friendly beneficiation and extraction method to ensure the minimum disruption to biodiversity and community. So this is what we offer. Like I told you that MECL can offer all the end-to-end exploration solution with a single roof, because we are having all the facilities. We are making the exploration proposal capable of doing the geological mapping with mapping, and we are formulating the proposal with the desktop studies, and based on the modern advanced techniques like remote sensing and all those things. We are having the ultra modern chemical lab capable of doing all the exploration value chain, including the critical minerals. And we are having the modern geophysical department, having with the modern equipments like gamma ray spectrometer and the GPR and MT, time domain electro. And now we are procuring the 2D, 3D seismic to develop our deep seismic exploration. And also our fleet is capable of drilling more than 1,500 meter in NQ. And we are also providing the consultancy services to the state government as well as the central government for auction and for this geological report preparation and feasibility studies. This is the MECL stand to ready to power India's critical mineral journey scientifically, sustainably, and strategically. Thank you.
Your investigation is going on there in the Raigad district of Chhattisgarh.
Yeah.
Where that in the Gondwana's clay,
Yeah.
you have analyzed REs.
Yeah,
How
yeah.
much the yttrium is also associated with that REs and lithium is there?
No, only we are getting the lanthanum, cerium, dysporium, and uranium, and we are not find any this yttrium in that. The total RE is coming around 1300. Actually, what happened? Whatever the samples they are giving, we are analyzing in our chemical lab. Initially, we used to do all the borehole, all the oration of the borehole drill. But now what happened? Now they have decided that to first you log the borehole with the spectral gamma and identify any RI, any gamma ray anomalies, and that zone only we are sampling now, and we are getting 1,300 to 1,500 ppm of total RI. And we are getting some vanadium also.
Okay, sir. And as I know that MECL is earlier working in the coalfield areas also in the same terrain.
Yeah.
Do you have any idea about the lithium associated with the intercalated coals, clay seam within a coal?
No. Yes, so far we have not encountered any lithium value. We are so many boreholes we are sampled and we analyzed in the entire horizon. Coal, sandstone, nickel, and all those coal horizons we have sampled, but we have not found any anomalous values of lithium.
Okay, thank you, sir.
For sharing with us how MECL is well positioned to help ensure India's critical mineral security and drive the national agenda of resource self-reliance through sustainable and innovative exploration. Now I would like to request our Honorable Regional Director, Sri Srikant R. Mantanwa, sir, to present a gift of love and affection to our esteemed speaker. Thank you, sir. So we have a slight change in the schedule. because of some official commitments, our lecture would be preponed. So our next invited talk would be delivered by Sri Neeraj Kumar Panda, Head Planning and Management Services Group, AMD. Over the course of his remarkable career, he has been primarily involved in the exploration of uranium and Wheatstone minerals. Sri Panda will deliver his talk on strategic outlook on the assessment, evaluation, and recovery of critical minerals associated with atomic minerals deposits of India. Once again, I'll request Sri Pritam Karmakar to introduce our esteemed speaker with all of us.
Sri Neeraj Kumar Panda completed his MSc Applied Geology from IIT Mumbai, followed by MTech from IIT Kharagpur. He pursued his career in AMD as Scientific Officer SC in 1995. He has made significant contribution in the exploration and augmentation of beach sand minerals. In addition, he also carried out subsurface exploration for unconformity type and sandstone type of uranium mineralization in Chhattisgarh and Satpura Gondwana basin respectively. Besides, reinterpretation of exploration data for Dumat area. Presently, Sri Panda is shouldering the responsibilities of Head PMSG and Assistant Director AMD in planning and monitoring the exploration activities of the Directorate. He is also looking after Mining Regulatory Group of AMD. He has published around 30 research papers of national and international repute. May I request Sri Panda to kindly on the stage.
Thank you, Mr. Karmakar. Good afternoon to everyone. Yeah, I'll be just talking the topic strategic outlook on assessment, evaluation, and recovery of critical minerals that is associated the atomic mineral deposits of India. So I'll be talking about the upstream segment of the critical value chain. Now, next slide, please. In the morning session, a lot of discussions has taken place. What are the atomic minerals? What are the critical minerals? And what are the strategic minerals? And the atomic minerals, people see, it is basically crucial for the nuclear power production, essential for national security, and it is related to radio isotopes and research, and it is foreign policy that again depends upon the foreign policy, and the trade is restricted to some extent, and they are fairly available in the geological domain, and their recovery that is also established. People see the strategic mineral, it is also in the coming in the same category. Here, you are besides to the nuclear application, it is having the defense application as well as the space application. But the critical minerals is altogether is have a different impact because they are the economic drivers. In the morning session, Pandit has given the nice examples to define what are the critical minerals. And their presence is restricted to certain region, and the recovery of these elements or minerals is also a challenging task. If we are having the RE resource, we are having around 8 million tons of RE resource in India, but we are not able to extract it. That is very limited. That extraction process is very limited for us. Though we are having the contributing 7% of the global resources, due to the recovery that how to recover all these things from the mineral itself, that is categorizing these elements to the critical sectors. And Government of India, they have defined the critical and strategic minerals into one group, and they have defined as the Part D of the MMDR Act, that is in 2023. And there also you will not see a distinction between the critical, which minerals are the critical and which minerals are the strategic. Both the minerals together they have put under the critical and strategic mineral. If I see it in the critical mineral, these are the 24 set of the minerals which I have written it: cadmium, gallium, glauconite, graphite, indium. This is known to everyone. And some of the minerals, they are also serving to the part of the atomic minerals. And if you'll see the strategic mineral as defined by the Niti Aayog, these are the some set of the elements that is strategic for us. So if you'll see the green color elements, whatever I have written it there, it is Re, titanium, zirconium, hafnium, lithium, beryllium, neodymium, and tantalum. They are helpful to the atomic nuclear power program. They are also the critical minerals. They are also the strategic minerals. Similarly, some of the minerals, that cobalt, nickel, PGE, uranium, tin, and vanadium, they are both strategic as well as the critical. So all the minerals, whether it is the critical minerals or the atomic minerals or the major minerals, they are governed by the Ministry of Mine is the legislation for this thing. And that is the MMDR Act 1957. They are governed by the MMDR Act as well as the rules that form therein after. So it is basically the rules, whatever I have written, that mineral auction rule that today we have heard a lot about from the GSI as well as the MECL. Then mineral evidence and content rules. Then MCR, that is mineral concession rules. And the AMCR, that is atomic mineral concession rules. And the mineral conservation and development rule. So all the minerals, whether it is the exploration or their mining, they are governed by the MMDR Act and the rules made there under. And this is the set of 12 minerals which was in the list of the atomic minerals. And subsequently it has been 6 of the minerals that have been delisted from the list of the atomic minerals because their government was in the opinion that it is having the more uses in the non-nuclear sector rather than the nuclear sector. They opened it for the private parties where they can participate in the exploration as well as they can go for the auction where is the composite license, prospecting plus mining list. And this is a list of the critical minerals. Whatever I have written, just given the dollar with the symbol of dollar. These are the elements, they don't form the deposit of their own. They're always associated as a element, means they're associated with some major primary ore minerals. They don't form their own mineral deposits. Rest of the minerals, they form their own deposits. In Indian context, if you'll see bearing few, if you see the Re, titanium, and phosphate, potash, and graphite, glauconite, rest are all these elements or minerals that we get it in association with some primary ore deposit. This already it has discussed in the morning. All the yellow highlighted things that has been explored and evaluated by AMD, and that element that molybdenum, cobalt, barium, there's highlighted with that red box. These are all associated minerals that we find in our atomic mineral deposits of India. So basically, I'll now come to the mandate of the AMD that we have given a mandate to identify and evaluate the atomic mineral resources or mineral resources of uranium, thorium, niobium, tantalum, lithium, and Re. And if you see the uranium, it is basically the strategic nuclear fuel element that catered to the nuclear power program of India. Similarly, the base and exploration, if you'll see, it is the thorium, which is associated with the mineral monazite. That is also a nuclear fuel element. In addition to that, we are getting the titanium, zirconium, hafnium, and Re that is associated with the base and minerals. And rare metals and rare earth groups. These are basically the critical elements that is for the clean energy and high-tech applications. These are the minerals that we are exploring, that is lithium, Re, niobium, tantalum, and beryllium. Besides to identification and evaluation of the atomic mineral deposits, we also carry out the pre-feasibility studies for the atomic mineral deposits, as well as we approve the mining plan for the atomic minerals. And last, we are in the geotechnical investigation in the site selection, and it is operated through 7 regional centers and 3 sectional offices. Now, if we'll see the critical materials value chain, that is basically, it is having the 3 segments, that is upstream, midstream, and downstream. And upstream, where our work is mainly confined. As exploration agencies, whether it is AMD or GSI or MECL, we are basically confined to the exploration and mining. And second, midstream is basically processing, refining, and metallurgy. And third part is the whatever the material that is giving as the end use product. And what is the position of the India's in this CRM value chain? We are fairly established and we are fairly functional only in the upstream segment. And still we have to do a lot of work in the midstream as well as the downstream segment. Since our inception, 1949, we have carried out the exploration starting from G4 to G1 exploration. And this is the end result of our exploration. We are having 47 uranium deposits, and that is 431 tons of uranium oxide. We are having 136 BSM deposits, that is 1309 million tons of heavy minerals that contain 13.15 million tons of monazite, as well as 38 million tons of zircon. And India's first hard rock carbonatite hosted RE deposit that has been established by AMD, and this has been, he has nominated GMDC to go for the mining of this deposit. That is in the Ambadongar, Gujarat. Besides that, we are having the Siwana ring complex that is potential for the RE deposits, but only the thing is here it is basically they are the HRE deposits as compared to the Ambadongar carbonatite. And first lithium deposit in pegmatite that we have established, that is in the Karnataka, that is 1800 tons of lithium oxide. Besides to that, we are collecting the critical elements or the atomic, whatever the minerals that will require for the nuclear power program, incidental to the prospecting operation, that is columbite, tantalite, beryl, lepidolite, and genotype bearing heavy mineral concentrate that we are collecting, incidental to our prospecting operation. We are 6 uranium provinces. I have just clubbed north and south Kadapa basin to 1, and this has the maximum uranium resource that we get it, and it is Tumlapalli group of deposits, Kapanuru, Lambapur, Chitrial. And the critical or the associated elements that we have established in this deposit is molybdenum, vanadium, copper, and lead. Similarly, North Delhi fold belt, that is in the Rajasthan, where a couple of deposits, Rohil, Kiratioki Jahaz, and Umra. Here also, if you see, it's the number of associated elements, that is molybdenum, vanadium, Re, all these things are there. Singhbhum copper belt, we are getting copper, iron, chromium, molybdenum, bismuth, nickel, and Res. And Bhima basin, it is copper, vanadium, and lead. And Mahadek basin, it is selenium, vanadium, and molybdenum. In all the deposits of the uranium, we are getting the association of the critical minerals, which I have highlighted in the red colored fonts. If you see all the uranium deposits, it is, if you see all these provinces, one element that is very common, that is molybdenum. And second, it is the vanadium. These two are very common in all the uranium deposits of India. Besides to that, that the base and we have established the economic heavy mineral suit that is containing a monazite, which is a mineral of thorium, uranium, as well as Re. Then zircon, that also containing the element zirconium as well as the hafnium. And ilmenite, rutile, leucoxene, that is again a critical element that we have classified, that is the titanium. Again, here I am telling we are having the sufficient resource of titanium. We are having 720 million tons of ilmenite, but still we are putting it in under the critical mineral. It is not a deficient. Our country is not deficient in titanium mineral resources, but finding out the end product, that is titanium metal or Ti2 pigment, that is the challenge for us. We don't have except one, that is KMML. We don't have anywhere the processing of the ilmenite to the final products that is taken. And RE deposits, that Amba Dongar, that is in addition to the RE, we are getting the magnesium, niobium, thorium, barium, strontium, and vanadium. And we don't have a deposit of niobium of its own in India. If you'll see the IBM book, mineral book, we are totally dependent. We are importing the niobium and strontium to maximum extent. So this is the one of the niobium that we are getting with the RA deposits. Again, the Tibana ring complex, niobium is also there, and zirconium. This is the first reporting. We are reporting the zirconium resource from the hard rocks that is in the Sivana ring complex. And pegmatite belts of India that contain the different elements: lithium, beryllium, cesium, niobium, tantalum, tin, yttrium, and Re. Now, this is the National Critical Mineral Mission. It has been announced by the government of India in January 25. They have earmarked a heavy amount to see that we'll have a resilient value chain. That three chains I was just talking about: the upstream, midstream, and the downstream. First step is what? You should have the material with you. That means you should have the minerals with you, so that you can develop, you can go for the midstream or the downstream. If first part is not there, then automatically second and third part is not there. That is where the upstream is very important for all the geological organization that we are looking for it. And Government of India, that they have liberalized in the acts as well as the rules, so that the private participations, prospecting, or through the composite license, they're encouraging the private parties to come inside. Now, what is the role of the AMD in this value chain, and what AMD contributes to this critical mineral resource assessment? AMD is an exploration agency as per the Geological Exploration Agency, that is a Section 4 agency of the MMDR Act. At the same time, AMD is also the regulatory authority for the atomic minerals. Hardly any organization will get it having the exploration agency as well as you are having the power to regulate the mineral. IBM, it is the regulatory authority for the non-atomic minerals. Though they are the exploration agency, but I don't think they're carrying out the exploration for the any mineral. Similarly, GSI, they are the exploration agency, but they don't have the regulatory authority. So AMD is poised between as an exploration agency as well as the regulatory authority. So we are having powers under us when we regulate the atomic minerals mining plans. AMD is approving the mining plans from 1990, but the power was given by Ministry of Mines to AMD in 2021. Approval of the mining plan is one part. Second part, whether the mining is going as per the approved mining plan or not, that requires to be checked in the field. You should have a power of entry and inspection to the mine site. Prior to 2021, AMD was not carrying out any entry inspection of the mines, but subsequent to 21, it is I think July 21, we are carrying out the inspection of the mines and we are directing the mines to go for the recovery of the minerals. They have to do the mining operation as per the approved mining plan. So what are the proactive steps that already AMD has taken in the form of SOP, Standard Operating Procedure? This is already in the line for the last 1 year. What we are thinking of the critical minerals, and already we are having a standard operating procedure where we are assessing the associated elements within the uranium ore zone. Uranium ore zone, what are the associated elements that we are assessing and evaluating? Second, it is the RE and lithium ore zone. What are the associated elements? Already SOP is there. Then quantification of the monazite, zircon, titanium bearing minerals. That also we are doing in the pitch pressures. And preliminary uranium tailing sampling. Nowadays, lot of discussions are going on the recovery of the critical minerals or elements from the tailing ponds. But I think this topic you must have heard for the last 1 year or so. But AMD is very proactive and we have taken this work during the COVID time, 2020. We have already taken some samples. I'll share some of the results. And we are submitting the geological report for any exploration program. I'll just, I'm going a little bit away because as a exploration geologist, we should know also after doing our work doesn't finish there. As a geologist, will be the happiest person when you will see the area where you have worked that is going for the exploitation. That is the dream of every geologist. So what happens after the work, we prepare a geological report and that is submitted to the state government. Then state government gives it to the mining list to the prospective lessee. So in all our geological report that we are submitting to the state government, that contains the resource of the critical elements or the associated elements in the uranium ore zone to the state government. That means we are communicating the state government. It is not the uranium is there. There are some associated elements, some critical elements that is also available ore zone. Now, in this context, still we are now refining our standard operating procedure. Okay, so these are the some previously what we are interested, we are just looking for the mineralizing zone. Whether it is the uranium zone, we are concentrating only the uranium mineralized part. But now in the ground surveys, we are also proposing to go for the critical element analysis for all major litho units. It may not be the number more. We can go for the compositing of the samples of the major litho units and we'll go for the analysis of this. Mineralizing zone, that is already in the practice. And when in the subsurface exploration, we are concentrating mainly on the ore zone. Now we are revising our SOP. We'll be going for the sampling of the overburden as well as the barren zone. In the barren zone, we'll go study the critical element that is associated in the major lithology, that is correlatable lithological units. And we are proposing one borehole in 1 square kilometer. That will be analyzing to get the first-hand information, whether it is in the overburden or the barren zone or the mineralizing zone, whatever this time. And previously, in the when we are drilling, we are concentrating only in the uranium ore zone. But there are certain zones which can be easily identifiable in the naked eyes. That is the alteration zones, as well as the sulfide zones. These zones has to be compositing and we'll go for the sampling of this thing. And this is what I have written it. This is already in the practice. That is already in our journal instruction. I think everybody must have seen it. And same thing will be extended to another 2 or 3 additional sampling horizons. Now, as a regulatory, this is as a exploration geologist, this is what we are planning to do. And now second is as a regulatory authority, we are having the power to instruct the mine owners or the mining lease holder. If we require certain samples, we can give them the directions. Under the rule 58, we are having the power, and within the rule 18, if you see, combining this rule, IBN and AMD can give the instruction to the leaseholder to sample where we want. That means we can instruct him, you sample the critical elements that is available in my mine phase. Otherwise, you can also instruct them to sample the tailing ponds. And at the same time, we can also instruct them to go for the development of the flow sheet, not the uranium or not the atomic minerals. You have to see whether pilot plant studies, whether the other elements can be recoverable. If it is recoverable, then it has to be included in the mining plan. And here, the support of the government is very much essential, because most of the time, everybody will be interested in the primary ore minerals, but the secondary, nobody wants. So that is where the government of India has to come forward, and some sort of help, financial help should be given to them. Keeping this view, we are planning to this standard operating procedure that we are planning. That is when they go for the mine development, they go for the geotechnical studies. Whatever the sampling procedure, that's SOP for the general exploration, we are going to request them or direct them to analyze the major units. Similarly, for the shaft sinking, shaft is there. If they are advancing the shaft or advancing the mining phase, there also we are going to direct them to collect the sample and analyze it. And during beneficiation, waste dumping, tailing, these are the 4 areas where we are planning to give the directions to the mining leaseholder to go for the sampling. But they will sample it, but will they be interested for the analysis part? Does all the mine having that facility to analyze? Here, it has to come that financial support, or whether it is financial support in terms of giving them the instrument to analyze the samples, or these samples can be sent to some laboratories where it can be analyzed. Here, the NMET fund may be utilized. Government of India is utilizing the NMET fund very judicious way for the exploration as well as the prospecting operation. The same thing can be extended to the mining leaseholder, so it will be beneficial for all. And every month, the mining leaseholder submit a monthly return. We'll insist them that any critical elements or any analysis report that has to be included, and it has to be in the any government organization, they can see these reports. And now I'll just coming a little bit about the mine tailings. This is now a lot of talks that is going on for the mine tailings. And what is happening after you take up the primary ore, the rest of the ore that is going to the tailings. And as there is no grinding and there is no milling is involved, it is assumed that it will be a source for recovering the critical minerals from the mine. So, and it is not that mine tailings is not being used. Different countries, if you see the Canada, European, United States, they are already recovering the critical elements from the mine tailings. And these are basically they're going for the hydrometallurgical process, whether it is ion exchange or solvent extraction, or they are going for the bioleaching or acid alkaline leaching. So these are the 3 processes they are generally following, but whatever that literature say, it is the bioleaching that is most beneficial for the critical elements that can be extracted from the mine tailings. But if we'll go for the recovery of the mine tailings, but first we have to assess how much quantity of the material is there. And this is a big challenge. And what should be our target when we are going for the sampling of the mine tailings? Should we concentrate more on the recent tailing pond or should we go for the older tailing ponds? Because in my opinion, we should go for the old mine dumps or old tailing ponds that is available. Because if you see over the years, the technology is advancing and whatever you are recovering in 1950s or 60s, that is 1% was the copper, that is the cutoff. Now we have come to 0.5% cutoff. So technology is advancing day by day. So you are recovering also, your low grade ore also you are recovering with the latest technology. So in my view, we should go for the old mine dump or mine tailing pond sampling in the past, because there we should get the higher concentration of these elements. And second thing, in order to assess the mining tailing pond, you should have the dimension, and it is not that superficial samples has to be taken. Entire column of the tailing pond needs to be sampled. That needs to be drilled. Somewhere it will be 10 to 15 meter. Then tailings, this tailings should be studied, whether their size factor has to be studied, their mineralogical factor, as well as the chemical factor. How much? Okay. Okay. Right. Then tailing, tailing, if you'll see, it will have the three parameters. One thing is what is the size wise, that is the physical characteristics. What is the chemical composition wise, that is the second characteristic. Third characteristics will be what is the mineralogy that is associated with it. Because if you'll see, if there is RE, there is scandium. Scandium is recovered from some of the tailings, but their recovery will be impacted if there is a RE or lithium in the system. If the tailing is containing RE, that will inhibit your recovery process of the scandium. So there it is the most important factor when we are going for the assessment of the tailing ponds. These things has to be taken into consideration. You should go for the physical characterization of the tailing. That means it is basically the size. Second thing, we should go for the chemical characterization. What are the different type of elements are there, and what are the different critical elements that is present. And third, what is the mineralogy. And technical feasibility, some extra that I have already told it, and regulatory concerns. Tailing ponds, if we'll get some uranium and thorium, then again it has to be come under the purview of the Atomic Energy Act, radiation protection rules. So these are the constraints. This is this is one of my last slide. This is a part that is taken up by all the officers in the eastern region as well as the southern region. If we'll see, this is the critical elements or the base metal association of the elements that is available in the ore zone of the uranium deposits. Copper, nickel, vanadium, cobalt, molybdenum, and totalary. This is the Singhbum shear zone deposit. Okay, 3 to 4 deposits. I have taken the average and taken it as range. Another, if you'll see the Tumlapalli group of deposits and see the number of samples that has been. It is close to 13,000 samples has been analyzed in the uranium ore zone to give, this is the quantity of the critical elements that is associated in the ore. But if you see the now tailing pond sampling, that is what we are having the 2 tailing ponds in the Singhbum shear zone area and 1 tailing pond in the Tumlapalli. If you see the ore, the critical element that is associated in the uranium ore zone, and you see the tailing pond, there is a drastic variation. Even if I take a mining and milling loss of 80% to 90%, and if I'm putting that factor also, still there is, I'm not able to justify whatever the figures are given. That is, so there is a loss when we are going for the processing. So AMD is in the opinion that it is better to develop the process flow sheet for all the elements in the uranium ore zone as given in the geological report. Whatever the elements that we are giving it in the geological report, we should develop a flow sheet first rather than targeting for the mine tailings. Okay, mine tailings may be a short-term goal, but in a long term or medium term, we should see that it is recovered in the first stage itself, not from the tailings, because tailing processing is also a difficult task. It will not be that easy. It is being done, but it may not be that easy because it will have the dust problem when you are treating the tailings. So there will be some constraints. So I'll just conclude. So now there is a need, if you want to make our upstream of the CRM value chain the strong, we have to establish the resource, whether it is the primary resource or the secondary. Primary means if it is having this own deposit or it is associated with our, already we are having the mineralizing zone, we have to estimate it. That is what AMD has already taken a proactive role, and from the G4 to G1 stage exploration, we are doing all the mineralizing zone sample analysis for the critical elements, and this will help the supply chain for availability of the mineral that is in the CRM value chain. Second, geological reports shall invariably include all the informations of the critical element that is associated with the core zone. That we are already doing it, and if it is extended to all the deposits, our critical mineral resource inventory will increase. Third, mineral concession proposal. Mineral concession proposal means when you are going for the prospecting or the mining list, there also they should think of the recovery of all the elements, not the primary ore. If you are submitting a geological report for the uranium, whatever the associated elements are there, they should see and they should approve the mining plan. They should insist on developing the flow sheet. And for this, we have to have the focused R&D efforts, and NMIT as well as the National Critical Mineral Mission. They're having budget. They have kept some budget for developing this R&D efforts. Center of Excellence, they're coming, and they're hopeful that they will be very helpful in developing the flow sheet. Now, second, another thing, just Pandesa was just asking to Bhattacharya sir, whether you have put the threshold. We cannot take all the tailings. Every tailing we should define the threshold for the tailing. And this is the stand of AMD. If just like your uranium ore, is the iron ore, it is having the different thresholds, 60% and above, 55% and above, 40 to 55%. Similarly, we should have it defined the threshold of the different elements that is in the tailing pond. Then another option we can look for when we are going for the recovery of the critical elements from the tailing ponds. You see if there are a number of tailing ponds are there, you give it to one person so that it will a bulk amount will be there. It will be economic for him to go for the extraction. Single tailing pond may not be. So these are some of the views of AMD, and this has already we have communicated to Ministry of Mines in our notes, that I thought this is the right platform to share it. The AMD's view on the assessment of critical elements in the ore zone, as well as a regulatory authority, how will facilitate the assessment of the critical elements in the existing mining. Thank you.
on the significance of critical minerals in India's economic, industrial, and clean, and the role of government and other agencies in promoting environmentally sustainable mining practices with net zero discharge. Now I'll request Chairman of the Organizing Committee and Regional Director, Sri Srikanta Mantapur sir, to present a memento as a mark of our gratitude to our speakers, Sri Venkapanya. Thank you, sir. Now we'll proceed to our next keynote address. Our esteemed speaker, Dr. S.K. Sarkar, Deputy General Manager, MOIL Limited, has a significant contribution towards exploration and development of natural resources, particularly different grades of manganese ore. So I'll request Sri Pritham Karmakar to enlighten us briefly about our speaker and his topic.
Dr. S.K. Sarkar, the gold medalist from NIT Raipur. He has completed his PhD from IIT ISM Dhanbad. He has more than 20 years of experience in mining, both open cast and underground. He will be delivering a lecture on manganese, critical raw material for steel industry, opportunities and challenges. May I request Dr. Sarkar to kindly on the stage.
Hello. So good afternoon to all of you. I am Dr. S.K. Sarkar, Deputy General Manager, Geology in MOIL Limited, Nagpur. MOIL Limited is a public sector unit under Ministry of Steel, Government of India, and producing almost 50% total production of manganese ore in the country. The manganese deposit of India is discovered in 1889, and it is almost, MOIL is almost 125 years old. And in 1962, Government of India has nationalized, and it is now MOIL Limited. As I already been told that almost 50% total production of the country is produced by MOIL Limited. We have 10 manganese mines in central India, that is in Madhya Pradesh and Maharashtra. We have also a ferromanganese plant and a EMD plant in Dongri Bujug mines. And we are also operating windmill and solar plant. And the consumption of mines, almost 60% is from our renewable resources. This is the achievement. Highest production. Exploration, we have also explored more than 1 lakh meter last year, and we are going for 1,20,000 meter in this year. You can see also the ore reserve added during this year is almost 17 million tons. It is huge in case of manganese. So why manganese? सुबह से हम लोग जैसे देख रहे हैं कि क्रिटिकल मिनरल एंड स्ट्रेटेजिक मिनरल के ऊपर हम लोग ज़्यादा डिस्कशन कर रहे हैं, बट इन केस ऑफ मैन्युफैक्चरिंग ऑफ एनी काइंड ऑफ बैटरी या स्टील, आपको स्मॉल पोर्शन ऑफ मैंगनीज लगेगा ही. द मेन इंग्रेडिएंट फॉर स्टील एंड बैटरीज आर मैंगनीज. If you see the average abundance of manganese in earth crust, that is 1000 ppm. In igneous rock, that is 0.068 ppm. In sedimentary rock, it is 2.6
to 0.5, and in metamorphic rock, it is 0.08. So if you see the total use of manganese, the metallurgical purpose, it is used 95 to 96% in metallurgical, and especially in form of alloys, that is ferromanganese and silicomanganese. And remaining part is used in manufacturing of dry cell, chemical, and others. If you see the total global and Indian scenario of manganese, so basically these are the 6 main producing and resourceful states in MP, Maharashtra, then Karnataka, Goa, Andhra Pradesh, Odisha. So if you see the total resources, it is almost 503 million tons in India. And MOIL is having 121.97 million tons. So if you see the production, total production, so total production is from South Africa is 42%. In India, it is only 6%. If you see the total consumption of manganese in India, that is 6.5 million tons. But we are producing now only 3.7 million tons. This is the total production of India, and this is total production of MOIL. So import is almost 5.5 million tons. And MOIL's production, average production in last 5 years is 1.44 million tons. Domestic production is around 3 million tons. So future, if you see the future outlook, as per National Steel Policy, the requirement of manganese will be around 11 million tons in 2030. So MOIL is also going for an enhancement of production, and we are planning to enhance our production up to 3.5 million tons by 2030. So focus on growth area, higher exploration. We are exploring more than 1 lakh meter per annum, enhancing the EC limit, taking up new shafts projects, increase the production capacity, and expansion the business opportunities in other states as well as in foreign. So if you see, we have joint hand with GMDC and explored Pani area and established 9.5 million tons of ore resources in Pani area. And we have already Ministry of Steel, Niti Aayog and DIPAM has already approved the project. And now we are going to start mining in this area. Similarly, we have also discovered resources in Chhindwara and Balaghat district. We have established 2 new deposits. JB is under process. Similarly, we are also exploring potential zone in Chhattisgarh. This is a new area, and almost 11,000 meter exploration already been carried out, and some boreholes have a positive intersection, and the geological report is under preparation. So if you see the entire chain of manganese, it is very important to explore more area to establish the resource in manganese, particularly in manganese, to enhance the resource base of country. Thank you very much.
For sharing with us the significant contribution by MOIL for creating an opportunity for India to build a robust critical mineral ecosystem. As the MOIL motto says, adding strength to steel. You definitely, sir, added perspective to our workshop today. Now, I would like to request Dr. R. Ramesh Babu, sir, to present a token of appreciation from us on the behalf of organizing our speaker. you, sir. As we proceed further, our next keynote speaker, Sri KL Mundra, Additional Director, Research and Development, AMD, will deliver his lecture to ABEX in virtual mode. I'd request the stage to connect to Mundra, sir.
Yes, I am connected.
Okay, thank you, sir. Okay, so we are proceeding. Sri Mundra is an outstanding geoscientist and is definitely one of the stalwarts of rare earth and rare mineral exploration activities of AMD. His keynote, rare metal and rare earth resource potential of Central India.
So good afternoon. I think there was some issue in separating. So anyway, I start my talk on rare metal and rare earth resource potential in Central India. I'll be mainly talking what AMD have been doing in last 4 decades in this area. You can see there are mainly 3 major terrains, Bastar Malkangiri pegmatite belt and the North Odisha pegmatite belt. In addition, we have got the vast terrain of Chota Nagpur granite gneissic terrain. So we'll be mainly discussing on niobium, tantalum, beryllium, lithium and yttrium resources in central part of India. So you can see here, this is the geological map of Bastar Malkangiri pegmatite belt. It spreads over almost 80 km by 2 to 3 km in a northwest southeast strike direction, and the major pegmatites, as you can see, are depicted through these small red dots. It spreads from Chhattisgarh to Odisha in the southeast. This Bastar Malkangiri pegmatite belt, as I said, is extend over almost 80 km by 2 km and spread in the states of Chhattisgarh as well as Odisha. These pegmatites are emplaced along Archean metasedimentary bankfall group and proteozoic granitoids of Palyam and Darba. And the individual size of pegmatites that varies from 50 to 200 meter. However, at some places it goes even up to a kilometer by 50 meter. The pegmatites, they are both simple unzoned as well as complex zone type, and mineralized pegmatites are very conspicuous with replacement zones like Grison and albitite zones. Here, 5 types of pegmatites have been identified. Is a simple unzoned type, partially differentiated, fully differentiated, which mainly contain beryl, columbite, tantalite, and cassiterite. These are the pegmatites of our interest. In addition, there are some replaced lepidolite pegmatites are available, which are also helpful for lithium exploration. The important minerals are beryl, columbite, tantalite, ixiolite, wugdenite, microlite, euxenite, hesshenite, monazite, and genotime. And these pegmatites, they are enriched in beryllium, niobium, tantalum, and Re in marginal to the granites. However, lithium pegmatites are exterior ones. Here we can see that in Bastar Malkangiri pegmatite belt, the important locations are Chalanpara, Metapal, Koyadungri, Churwada, Badanpal, and Adwal. And majority of these are associated along the margin of granites and metabasics. And they are all zone type of pegmatites. Unzoned pegmatites are not mineralized, and the important minerals, as I have said, are columbite, tantalite, beryl, and lepidolite. This is one of the erstwhile plant, where small scale collection of niobium tantalum was going on in the past years. Now, of course, it has been closed. On surface, if you see, there are very tiny occurrences of pegmatites. You have to look in a very with a very detailed examination. Only you can see that some of the quartz core, when you excavate, fully differentiated pegmatite is exposed, where we can see the mineralization of beryl and columbite tantalite. Another photograph of Chalanpara pegmatite, where you can see that it has got slightly better extension, and quartz core along with all the zones are fully developed here. These are some of the assessment criteria where the work was mainly concentrated on assessment of gravel derived from these pegmatites. You can see that the pits of 1 meter by 1 meter by 1 meter size are dug in 10 meter by 10 meter interval, and the cutoff grade was kept at 100 gram per ton of columbite tantalite. So you can see out of so much of area, only a small part, the concentration of columbite tantalite in the vicinity of the pegmatite is identified. Another area, as I said, we are working in North Odisha. Here you can see the area lies between Sundargarh and Jharsuguda. The detailed map I'll just show in the next slide. But you can see here that Northern Odisha is having potential pegmatites, and the important localities are Kolabira and Pandikimal in Jharsuguda district. There we get swarms and clusters of pegmatites which are intrusive into the granite gneiss and at the contact of granite gneiss and amphibolite. Here also we get pegmatites which are both simple unjoined as well as complex. They are well joined type. However, the fully differentiated and joined pegmatites are only carrier of rare metals like columbite, tantalite, and beryl. Here also you can see that some of the important localities are Pandikimal, Jangapara, Nayak Bandpali, Burpi Dungri, Bathlera, and south of Kolabira, which are hosted by granite gneiss at the contact of granite as well as amphibolite, and the extension is seen for about 10 to 50 meter in width and about 100 to 400 meter in length. And important minerals identified are columbite, tantalite, beryl, lepidolite in these pegmatites. You can see the detailed geological map. You can see that these are the localities: Jangapara, Pandikimal, Burpi Dungri, Nayak Bandpali, where we get the granite gneiss, amphibolite, quartzite, and pegmatites. So these are fully differentiated pegmatites, and they are important for rare metal mineralization point of view. Here I want to just emphasize that so far AMD has been working only in the gravel zone, that is occurring from 1 meter to 2 meter depth, and no detailed exploration like drilling has been done. So we do not have much idea about the depth extension of these pegmatites, because the work has mainly been done for the limited demand of Department of Atomic Energy, since these minerals are now critical to the nation, and we can integrate our surveys for deeper level of exploration. The another area, you can see that Jangapara, we have done only surface work, and on a small scale, these pegmatites have been worked for winning the area. You can see the occurrence of beryl in quartz. You can also see the columbite tantalite pockets in the dugout pegmatite. And this is how the jigging operation in field is carried out for collection of columbite tantalite. Another area I want to emphasize is Korba district of Chhattisgarh, where some lithium shows were available, and one block was also auctioned by Ministry of Mines. We have also carried out some work in Churi Garthada Atmar tract of Korba district, and we can see that there are a number of pegmatites which are emplaced in phyllites, and they are having the trend of northeast southwest as well as east-west, and the main minerals identified are spodumene. You can see the big layers of spodumene and lepidolite in the pegmatites, and this you can see that these are the different pegmatite lenses which are all mineralized with respect to spodumene and lepidolite. Here the extension, you can see that these pegmatites vary from 5 to 10 meter in width, as well as they go in strike up to 150 to 160 meter. So here spodumene, lepidolite, genotime, garnet, rutile are identified in megascopically as well as thin section study. And these pegmatites have shown anomalous lithium, sometimes going beyond 1%, and cesium also goes up to a few thousand ppm. Another area is a vast terrain of Chota Nagpur granite gneiss complex, which has the younger granitic intrusives of 800 to 900 million years. So the area near Kunkri in Jashpur district has been worked in detail by AMD, where the riverine placers, you can see the Siri River, Champajaria Nala, and Baljora Nalas. Few nalas are fed through younger granitic terrain, which contains genotime as a potential, as an important RE mineral in addition to monazite and others. So these placer bars have been developed over a period of years in these areas, and they are now worked on a smaller scale to collect the heavy rare earth bearing mineral, that is genotime. So these are the various placer bars. You can see how because they are associated with genotime and monazite, we are using the radiation monitoring systems. They are done evaluated through auger hole sampling and penning. You can see these golden color minerals are mainly genotime and monazite. And this is the flow sheet, how these riverine placers, river sands are being processed to get the pure concentrate of genotime and monazite. So the raw sand contains only 0.5% HMC, which is fed to spiral and table through bucket elevator and trommel, which gives a pre-concentrate, which gives 3 to 5% genotime, which is further processed in magnetic separation unit. There we can get the pure concentrate of genotime and monazite. So monazite is mainly LRE mineral and genotime is mainly HRE mineral. So these pure concentrates are stockpiled for the use of Department of Atomic Energy on a very small scale. These are some of the photographs which shows the small scale recovery operations. Many of the AMD as well as GSA trainee officers, they keep coming to the area for a first-hand exposure to these areas. So I want to only emphasize that areas under central region, they have been investigated for RM and RE potential on a very moderate scale. Just very surface work has been done. Some of the areas like in Bastar, we could not venture deep within the jungle because of insurgency. Now the situation is changing. So these areas can be taken up on an integrated way by using various exploration methods. So we can deploy some drilling as well as other geophysical techniques. Now gravity technique can very easily tell us about the occurrence of pegmatites deep within. So these areas, as I have said, that Bihar Bastar Malkangiri pegmatite belt, North Orissa pegmatite belt, and parts of CGGC, they hold enormous potential for further exploration, and there is a need for integrated exploration. As we have seen that lithium was never worked in the central India, but Gada, Tada, Katgora, these areas is now coming up, and first time we have identified spodumene as well as lepidolite in number of pegmatites. More than 50 pegmatites have already been established by surface work, and drilling is likely to commence within a month for this very important lithium mineral. In addition, beryllium, niobium, tantalum, and RE are also associated in this area as well as other terrains. So my only suggestion that we should go for further exploration by deploying drilling as well as geophysical techniques to establish full potential of this very important terrain of central India. Thank you.
Thank you, sir, for a detailed and impactful presentation. It's truly fascinating to see how unlock its potential and become a key region for strategic exploration and resource development to meet growing global demand of rare metals and rare earth elements. We are really sorry for the technical glitches we faced during our presentation. Thank you again for sparing your time with us. Sir, please accept a token of gratitude from us at your office.
Thank you.
Thank
you very much.
Thank you, sir. So now let us move to the last keynote address of this session. Because we are facing some technical glitches, the scheduled virtual mode lecture we are postponing after tea. So our next presentation would be by Sri Vikas Kumar, Senior Manager, Geology, Mineral Exploration and Consultancy Limited.
Today my presentation is on the unlocking the critical of having anomalous titanium, vanadium, and gallium concentration in Tikaria area in Kutni district of Madhya Pradesh. Coming to the starting from the critical minerals. Critical minerals are essential, as we all know that it is essential for economic development and national security, and lack of ability or even concentration of existence means the criticality. Because of this criticality, these are termed as critical minerals, and there is a problem with the extraction process also, and with the beneficiation process also. So there is supply chain vulnerability and disruption of these minerals. So because of these points, these minerals are called critical minerals. And why critical minerals are required? These are the sources of renewable energy. These are invariably used in electronics, aerospace, and defense industries. And it supports India's ambition for self-reliant India that we know as Atmanirbhar Bharat initiative by Government of India. And these critical minerals are also required as a necessity for achieving India's net zero carbon neutrality target, and it is to be achieved by 2070. And more exploration of these critical and strategic minerals will reduces the dependency on the imports of these minerals and will strengthen the national security. Identification of critical minerals. All these minerals were present in the earth geologically and geographically from the past several years, but to which mineral we have to focus? There was a need of identification of critical minerals. So the Ministry of Mines constituted a committee in November 2022, and they have identified 30 critical minerals which were essential for India's needs. These are the list of all the 30 minerals. We all know about that. And after that, amendment was taken place in the MMDR in the 2023, in August 2023, to be specific. And in the MMDR, in the Part D of the Schedule 1, these 24 minerals were identified as critical and strategic minerals. These are the list of all these minerals, 24 minerals. So now coming to the National Critical Mission. National Critical Mission was introduced in July 2024 and was approved by Union Cabinet on 29th January 2025. And it has a time frame of 7 years from 24 to 2031. And the total budget of this national critical minerals is allocated as 34,300 crore, which will attract the direct public spending of 16,300 crore, and expected PSU investment is 18,000 crore. So what is the objective of National Critical Mineral Mission? To secure critical minerals for economic growth, green transition, and national security. What will be the key focus area of this mission? More and more domestic exploration and resource development, reducing the import dependency from other countries, strategic international collaboration with for critical and strategic minerals, and promoting recycling and sustainability. So why this mission is important? It will be as work as a backbone for sectors like EVs, electronics, aerospace, defense, and renewables. And it will be a pillar of Atmanirbhar Bharat. So highlights of National Critical Mission, Critical Mineral Mission. Integrated value chain development designed to ensure sustainable, resilient, and self-reliant critical minerals value chain across exploration, processing, and recycling. Strategic phased approach that will be aligned with short, medium, and long-term goals. Balance implementation of these short-term goals and long-term goals. These are the some highlights. Increasing domestic critical mineral production, acquisition of critical mineral assets abroad, recycling of critical minerals, trade and markets, more and more scientific research and technological advancement as far as critical mineral is concerned, and training of human resource for exploration and production of these minerals, and developing effective funding, financing, and fiscal incentives. So, auction of critical minerals and amendment in mineral auction rule. Amendments to the mineral auction rule have empowered the central government to auction critical minerals under exploration license, composite license, and mining lease. The Ministry of Mines, Government of India has appointed MECL as the technical advisor for auctioning blocks of critical minerals. This auction of critical and strategic mineral is going on in different tranches. Total 5 tranches has been completed, and 6 tranche is under process. So these are the 34 blocks in different tranches. 34 blocks has been auctioned. Out of these 34 blocks, 5 blocks belongs to MECL, in which one block is in for phosphorite in Uttar Pradesh, one block is in for graphite in Karnataka, and 3 blocks are for graphite in Odisha. Out of these 5 blocks, one block which is of phosphorite in the Lalitpur district of Jhansi, it falls in this central India region. Now coming to the MECL contribution in critical mineral exploration, we have successfully completed 62 number of blocks till date and contributed around 2,672 million tons of critical mineral resource to our country. Presently, 35 number of blocks for critical minerals are under execution. Here I can want to say that out of these 62 blocks, 13 blocks falls in the central India region, and out of these 35 blocks which are running for critical minerals, out of these 35, 8 blocks are falling in the central India region. And MECL has done collaboration with HCL and NALCO to form CABIL to explore overseas assets. These are the list of 13 blocks which in which exploration has been done by MECL in central India, and these are the 8 blocks in which exploration for critical minerals in central India is going on. Now I will come to the case study that I am taking in my presentation, that is of Tikaria block. The Tikaria G4 block was taken for iron and manganese initially, and it falls in the Agori formation of Mahakoshal group, which is of Paleoproterozoic age. The lithologies which are present in this block is quartzite, ferruginous quartzite, dolomites, phyllites, metabasalt, and laterites. Basically, these laterites are aluminous laterites in which we are getting the content of anomalous content of titanium, vanadium, and gallium. This is the location of the Tikaria G4 block in the Mahakoshal group. This is the location map of the Tikaria block on the Survey of India topo sheet number 64A by 6. Total area of the explored block is 58.7 square kilometer, and it falls in the Slimanabad Tehsil of Katni district in Madhya Pradesh. These are the highlights of Tikaria block. Actually, I have said earlier also that this block was taken for the exploration, G4 exploration for iron and manganese on the basis of the ferruginous bands present in the area, reported in the area. So initially when we had done the surface sampling and mapping, we have encountered several samples in which we were getting good good content of iron. But when we proceed to the subsurface, that when we had done trenching, the iron concentration was decreasing. But the good thing was that Al2O3 content that we were getting in on the surface, it was continuing on the subsurface also. So we had for in that line we have proceeded for the drilling and identified several lateritic aluminous laterite exposures in the area, and we have selected 12 number of such exposure and drilled 12 number of boreholes, each one borehole in each of the laterite exposure. So when we were getting good content of Al2O3, an idea had come that we should analyze for the titanium, gallium, and vanadium. Initially, since this block was not taken for bauxite or aluminous laterite, so these three minerals were not given in our NQT. So when we analyzed some of the samples for titanium, vanadium, and gallium, we had got good result. And in this way, this idea has completely changed the course of the exploration in this block. So in XRD studies also, we have got that major mineral constituent revealed from XRD analysis are gibbsite, hematite, dikite, magnetite, ilmenite, goethite, anatase. Anatase is the mineral form of titanium dioxide, kaolinite, and gibbsite, illite. Vanadium is found in the association with titanium, ilmenite, and magnetite, and primary source of gallium worldwide is bauxite. Gallium is adsorbed in the lattice of gibbsite and diaspore, and we are getting gibbsite in this area. This is the geological map of the Tikaria block. The major lithology which are present in this Tikaria block are phyllites. These are the phyllites. Most of the parts is covered by phyllites, and these red color bands are aluminous laterites. Green color bands are basalt and metabasics, and this blue color are dolomites. Now, outcome of the G4 exploration in this block. So we had carried out 215 meter of drilling in 12 number of boreholes, and you can see the zones for Al2O3 in first this table. So out of these 12 boreholes, we are getting above the cutoff grade in 10 boreholes. We are getting aluminous laterite in 10 boreholes above the cutoff grade. And for titanium we are getting good above than cutoff value in 9 number of boreholes. And for vanadium, we are getting more than cutoff value in 8 boreholes. And for gallium, we are getting in 4 boreholes, we are getting good values. So from 1 meter to 15 meter of zones for all these 4 elements, we are getting in these boreholes. So strategic importance of titanium, vanadium, and gallium. Titanium is invariably used in aerospace industries, defense sectors, and making in pigments. And vanadium is used in making steel alloys and energy storage, VRFBs, vanadium redox flow batteries. And gallium is invariably used in semiconductors, LEDs, and solar panels. And these 3 minerals supports net zero emission 2070 goals, and Atmanirbhar Bharat of Government of India. These are the global comparison of laterite hosted critical mineral deposits. In the first column, I have taken the data of Tikaria block. The second column, this is the South China area, and this is the Carajás, Brazil, which is in the northeastern part of Brazil, and this is Cape York, Australia, which is in the northeastern part of Australia, northeastern part of Queensland of Australia. So coming to the comparison, as far as gallium content is concerned, in Tikaria we are getting a range of 54 to 61 ppm of gallium. In South China we can see that the range is 50 to 150 ppm. In Carajás, Brazil, it is 30 to 80 ppm, and in Cape York, Australia, it is 40 to 80 ppm. So our Tikaria block is coming in the line of these three important deposits for these minerals. And coming to the vanadium content, our Tikaria block contains 5. I'm just quoting the above than 50 ppm for gallium and above than 500 ppm for vanadium. So average vanadium content in Tikaria we are getting 511 to 917 ppm. In South China it is less than 100 ppm. In Carajás, Brazil, they are getting very good values, 600 to 1200 ppm, but our Tikaria block is falling in line with that. And in Cape York, Australia, vanadium percentage is minor to moderate, 200 to 400 ppm. As far as TiO2 content is concerned, in Tikaria block we are getting up to 4.66% of TiO2, ranging from 2.01 to 4.66, and in South China it is low to moderate, 1 to 2%, and in Carajás, Brazil is high in ilmenite rich profiles, greater than 5% also, and in Cape York, Australia, it is moderate, 2 to 3%. So this is the table in which we can see how our Tikaria block and this region is placed as compared to the other blocks in which we are getting good values of these minerals. Summary of Tikaria block. This Tikaria G4 block is the part of Mahakaushal greenstone belt comprising of the supracrustal metavolcanic and metasedimentary sequences and comprise of rocks of Agori formation of Mahakaushal group and later intrusives. Key findings from Tikaria block, I have already mentioned that we are getting high-grade aluminous laterites, gallium up to 61 ppm, range is 54 to 61 ppm, vanadium up to 917 ppm, 511 to 917 ppm, and TiO2 in the range of 2.01 to 4.66%. And zone of mineralization for all these elements is ranging between 1 to 15 meter in boreholes. So MECL has carried out 215 meter of exploratory drilling in 12 number of boreholes, and we have estimated resources for all these aluminous laterite. Aluminous laterite we have by polygonal method we have estimated resources of 14.81 million ton, and for TiO2 we have estimated 15.45 million ton. For vanadium we have estimated 12.32 million ton, and for gallium we have estimated 2.44 million ton. Now, way forward of this block, just I am concluding. Substantial laterite area of, we have narrowed down area up to 11 square kilometer, which is falling in the western part of the Tikaria block, that identified as Sansarpur Bhula sub-block, and it will be upgraded to G3 level and aimed to add significant resources of these three important critical minerals with higher level of confidence, and it will enable to auction this block under the National Critical Mission. And this initiative will strengthen the domestic supply chain for titanium, vanadium, and gallium and support India's clean energy and technology ambitions. These are some of the field photographs of aluminous laterites. These are the aluminous laterite core we are getting in the borehole. Thank you very much. Any question?
What is the basement rock of this laterites? And you have not analyzed it for nickel. Or nickel you have analyzed in?
No, sir. In the surface sample, we have not got good values for nickel. That's why we have not proceed for in borehole.
All laterites are worldwide analyzed for nickel. Without nickel analysis is not complete. Second thing, what is the parent rock from which these laterites have been derived?
Ultra basic, sir.
Yeah, so you must go for in your X-ray diffraction also mineralogy. I couldn't
Definitely, when we will upgrade the block, we will.
I couldn't find any mineralogical support for gallium. Gallium is 50s. 50s is block.
Sir, it is associated with
gibbsite
the
and bohemite.
yes, sir. It is associated with the gibbsite. I have mentioned there.
Yeah, but garnierite couldn't you find?
No, sir.
Ultra basic, it should give garnierite. Thank you.
Okay.
Thank you, sir. Thank you, sir, for presenting a fascinating study on Mahakushal Belt in Madhya Pradesh as a major source of critical minerals like aluminium, titanium, vanadium, and gallium to support India's strategic goals of reducing import dependence and promoting mineral self-reliance under the Atmanirbhar Bharat initiative. I now request Sri Rajiv Ranjan sir, convener, Organizing Committee ACMR 2025, to present a token of appreciation to our speaker, Sri Vikash Kumar. Thank you, sir. With that, we conclude our second technical session of today. It's now time for a short break. I sincerely thank reporters of this session, Sri Ritesh Yadav and Sri Ajay Mishra, for their support. We invite all the participants to join us for a cup of tea in the adjacent hall. We'll reconvene in 10 minutes for the next session. We have more fascinating lectures coming up, so please be on time. So without wasting much time, let's delve into the lectures. So our first keynote lecture of this session would be delivered via virtual mode. We are pleased to have Sri Sanjay Kankane, Joint Director Geology, DGM Chhattisgarh, with us via WebEx today. Welcome, sir. Hope I'm audible to you.
Yes, yes.
Thank you, sir. Sri Kankane will deliver his lecture on critical and strategic mineral hunt and the state of Chhattisgarh. Now I request Sri Pritham Karmakar to give us a brief introduction about our speaker today.
Sri Sanjay Kankane began his career as a geologist in 1991 with the Directorate of Geology and Mining (DGM). In 2006, he was appointed as Under Secretary in the Mineral Resources Department, Government of Chhattisgarh. He later served as the regional head at Bilaspur, overseeing the geological exploration activities in the Bilaspur and Sarguja divisions of Chhattisgarh. Currently, he is the Joint Director, DGM Chhattisgarh, responsible for supervising and planning of geological exploration activities across the state and managing the auction of mineral blocks. He is also Chief General Manager, Chhattisgarh Mineral Development Corporation, CMDC. His major contribution is He played a key role in identifying the world's largest kimberlite pipe at Tokapal area in Bastar district. May I request sir to start his presentation?
Good evening, all of you, and thank you very much, AMD, to invite me for giving an opportunity for giving this lecture. So my short lecture is on a critical and strategic mineral hunt in state of Chhattisgarh. Next. So first, I am giving my congratulation from the Directorate of Geology and Mining, Chhattisgarh, to the Atomic Mineral Division for exploration and research on its 75th anniversary, celebrating excellence in exploration and research in strengthening the nations. And I am very much congratulations to all the members and geologists and scientists to Atomic Mineral Division. Next. सर, हमारा ये जो शार्ट प्रस्तुतिकरण है, हम इसमें सिर्फ 4 पार्ट पे ही सभी वैज्ञानिकों को अवगत कराएंगे। इसमें हम पहले स्टेज में कवर कर रहे हैं कि नीड ऑफ एन आवर अ क्रिटिकल स्ट्रेटेजिक एंड डीप सीटेड मिनरल्स, जिसमें सभी बहुत ज़्यादा पूर्व के प्रस्तुतिकरण वैज्ञानिकों ने अपना मत दिया हुआ है। एंड देन हम बात करेंगे क्रिटिकल एंड स्ट्रेटेजिक मिनरल पोटेंशियल इन छत्तीसगढ़ में, जो शॉर्ट हमारा प्रेजेंटेशन है, एंड वॉट एवर द एफर्ट बाई DGMCG इन क्रिटिकल मिनरल स्ट्रेटेजिक एंड एक्सप्लोरेशन, उसके बारे में हम थोड़ी सी बात कर सकते हैं। एंड what is the scope for betterment of critical and strategic mineral in worldwide, in India wide, and also in our state. Next. So what is the need of an hour in critical and strategic mineral इन छत्तीसगढ़, इसके बारे में तो अभी सभी लोगों ने काफ़ी कुछ बताया हुआ है। हम सभी जानते हैं कि हमारे इकोनॉमिक डेवलपमेंट, टेक्नोलॉजी इनोवेशन एंड नेशनल सिक्योरिटी के लिए क्रिटिकल एंड स्ट्रेटेजिक मिनरल एंड डीप सीटेड मिनरल की कितनी आवश्यकता है, इसके बारे में हम और आगे बात अभी मैं ज़्यादा नहीं बोल पाऊंगा, क्योंकि इसके पहले के प्रस्तुतिकरणकर्ताओं ने काफ़ी अधिक जानकारी हमें दे रखी है। हम ये देखेंगे कि हमारी जो मिनिस्ट्री ऑफ माइंस की एक कमेटी थी, जिसने हमारे 30 क्रिटिकल एंड स्ट्रेटेजिक मिनरल्स को आइडेंटिफाई किया हुआ था, जिसको कि जिसमें कोबाल्ट, लिथियम एंड रेयर अर्थ मिनरल्स थे। नेक्स्ट, इसी के आधार पर हमारे मिनिस्ट्री ऑफ माइंस ने MMDR एक्ट के पार्ट डी में 24 मिनरल्स को जो क्रिटिकल एंड स्ट्रेटेजिक मिनरल्स के तहत आइडेंटिफाई किया है। आज ये प्रस्तुतिकरण के लिए हम थोड़ा सा उन्हीं चीज़ों पर छत्तीसगढ़ के परिवेश में ही प्रकाश डालेंगे। नेक्स्ट, हम छत्तीसगढ़ की ज्योग्राफी के बारे में हम थोड़ा सा सभी लोगों को बताना चाहेंगे कि हमारा छत्तीसगढ़ जो है, सभी को बताना चाहेंगे कि 2000 में 26 स्टेट्स के रूप में आइडेंटिफाई किया गया और कार्व आउट किया गया था फ्रॉम मध्य प्रदेश से। और हमारा जो स्टेट है वो सिर्फ इंडिया के 4% एरिया का ही कवर करता है, जो करीब 135 लाख स्क्वायर किलोमीटर का है। हम यहाँ पर जो मिनरल प्रोड्यूस करते हैं, जिसकी वैल्यू करीब टोटल इंडिया के प्रोडक्शन के 16% होती है, और हम अपने हमारा स्टेट जो है वो 11% कंट्रीब्यूट करता है GDP में इंडिया के लिए। हमारी यहाँ पर जो इंडस्ट्रीज हैं, उसमें 80% इंडस्ट्रीज जो हैं वो मिनरल बेस्ड इंडस्ट्रीज ही हैं। हमारे यहाँ टोटल 33 डिस्ट्रिक्ट्स हैं और 146 ब्लॉक्स हैं। नेक्स्ट सर, ओवरऑल जियोलॉजिकल फॉर्मेशन के बारे में हम यहाँ पे थोड़ा सा चर्चा करेंगे। तो हम ये देखेंगे कि हमारे यहाँ जो भी जियोलॉजिकल फॉर्मेशन है वो आर्कियन से मीसोजोइक तक के सभी प्रकार के फॉर्मेशन मिलते हैं, और लगभग 28 प्रकार के मिनरल्स हमारे यहाँ रिपोर्टेड ऑलरेडी हो चुके हैं। हम ये देखेंगे कि हमारा जो आर्कियन पार्ट है, जो 4,000 से 2,500 मिलियन ईयर्स में मोस्ट ऑफ दी सदर्न पार्ट ऑफ छत्तीसगढ़ में ये कवर करता है, जिसमें हमारे पास टिन, लिथियम के अलावा टंगस्टन, बेरिल, एमराल्ड एंड अदर प्रीशियस स्टोन्स भी मिलते हैं। हमारे जो है ईस्टर्न पार्ट ऑफ जो छत्तीसगढ़ में है, उसमें आर्कियन टू प्रोटोजोइक के 2500 to 1600 मिलियन ईयर्स की अबाउट की रॉक्स मिलती है, जिसमें हमारे क्रिटिकल स्ट्रेटेजिक मिनरल एंड आयरन ओर के साथ आरी, बेस मेटल, ग्रेफाइट, गोल्ड, डायमंड, लिथियम एंड आयरन ओर एंड अदर मिनरल्स भी यहाँ पर मिल रहे हैं। पैलियो प्रोटोजोइक एंड मीसोजोइक के रूप में हमारे यहाँ गोंडवाना सुपर ग्रुप और छत्तीसगढ़ बेसिन की रॉक है, जिसमें लाइमस्टोन, डोलोमाइट एंड कोल के साथ डायमंड, फास्फोराइट, जिप्सम, ग्लूकोनाइट, यूरेनियम, बेस मेटल, गोल्ड एंड पीजी, निकल, क्रोमियम की भी उपलब्धता ज्ञात हुई है। मीसोजोइक और सिनीजोइक्स में हमारे पास डेकन ट्रैप के साथ डेकन ट्रैप के पास जो है वो बॉक्साइट के डिपॉजिट हैं, जिसमें काफी अच्छी मात्रा में लेटेराइट में आरी, वेनेडियम, गैलियम की भी उपस्थिति दर्ज हुई है। नेक्स्ट, हम क्रिटिकल स्ट्रेटजिक एंड डीप सीटेड मिनरल के पोटेंशियल्स के बारे में यदि हम बताएंगे कि हमारे पास जो हम पोटेंशियलिटी बता रहे हैं, जो हमारे यहाँ पे अभी तक किए गए एक्सप्लोरेशन के कार्य हैं, हमारे यहाँ पे जो ऑक्शन ब्लॉक आइडेंटिफाई किया है, या जो हमारी एजेंसीज यहाँ पर एक्सप्लोरेशन के कार्य कर रही है, तो हम नॉर्थ ऑफ छत्तीसगढ़ के बारे में देखेंगे तो अभी तक हमने 3 बॉक्साइट और 2 ग्रेफाइट और एक ग्रेफाइट एंड वेनेडियम का ब्लॉक ऑलरेडी ऑक्शन किया हुआ है। एंड जो एग्जिस्टिंग माइनिंग लीज हैं, जिसमें 3 बॉक्साइट माइंस और 1 ग्रेफाइट की माइंस है ऑलरेडी एक्सप्लोरेशन के लिए। यहाँ पे 3 ग्रेफाइट और 1 आरी और 4 बॉक्साइट के ऑलरेडी प्रोजेक्ट्स चल रहे हैं। इस प्रकार से यदि हम देखेंगे तो इस क्षेत्र में अभी भी ग्रेफाइट, वेनेडियम, गैलियम और आरी के लिए फर्दर एक्सप्लोरेशन के लिए प्रोजेक्ट्स लिए जा सकते हैं। नेक्स्ट, हमारे ईस्टर्न छत्तीसगढ़ के बारे में बात करेंगे, जो गोल्ड, वेनेडियम, गैलियम एंड आरी के लिए काफी अच्छी मात्रा में यहाँ पर उपलब्धता है। हम इसके परिवेश में देखेंगे कि हमारे पास ऑप्शन ब्लॉक में 1 गोल्ड और 5 बॉक्साइट ब्लॉक के हमने ऑलरेडी ऑप्शन किए जा चुके हैं, जहाँ पर एग्जिस्टिंग 9 बॉक्साइट की माइनिंग लीज चल रही है। तथा एक्सप्लोरेशन के लिए यहाँ पे 6 आरी और आरी एंड लिथियम, गोल्ड के 2 और रेयर मेटल्स की 1 ब्लॉक को हम एक्सप्लोरेशन, हमारे यहाँ की कुछ गवर्नमेंट एजेंसी, सेंट्रल गवर्नमेंट की GSI और MECL के द्वारा एक्सप्लोरेशन का कार्य किया जा रहा है। नेक्स्ट, हमारे यहाँ जो प्रथम इंडिया का ऑक्शन ब्लॉक है लिथियम का, जो कटघोरा कोरबा में आइडेंटिफाई किया हुआ है और जिस पर हमने कंपोजिट लाइसेंस ऑलरेडी ग्रांट कर दिया गया है। एंड एक्सप्लोरेशन के अदर इस एरिया में हमारे पास 1 आरी एंड अदर मिनरल्स एंड 1 फास्फोराइट के एक्सप्लोरेशन के प्रोजेक्ट्स यहाँ पे चल रहे हैं। तो इस एरिया में भी अभी भी लिथियम के कुछ और ब्लॉक्स आने की संभावना हो सकती है। यदि हम छत्तीसगढ़ के इस जो आइडेंटिफाइड एरिया है, जिसमें गोल्ड, टंगस्टन, निकल, क्रोमियम, पीजी और ग्लूकोनाइट्स के भी हमारे पास यहाँ पर उपलब्धता मिली हुई है, जिसमें ऑक्शन ब्लॉक के रूप में 2 ग्लूकोनाइट के, 2 निकल, क्रोमियम एंड पीजी और 1 गोल्ड के डिपॉजिट्स, 1 गोल्ड का ब्लॉक हमने ऑलरेडी ऑक्शन किया हुआ है। और फर्दर एक्सप्लोरेशन के लिए यहाँ पे गोल्ड के 2, ग्लूकोनाइट के 5, आरी का 1, फास्फोराइट का 1 और टंगस्टन का 1 ब्लॉक यहाँ पे ऑलरेडी एक्सप्लोरेशन के कार्य के लिए विभिन्न एजेंसियों के द्वारा लिया गया है। नेक्स्ट, हमारे वेस्टर्न छत्तीसगढ़ के बारे में बात करेंगे तो यहाँ पे फास्फोराइट, कॉपर, लेड, जिंक एंड गोल्ड के काफ़ी अच्छी संभावना प्राप्त हो सकती है, जिसमें ऑलरेडी हमने 2 फास्फोराइट और 1 गोल्ड का ब्लॉक ऑक्शन किया जा चुका है। एंड एक्सप्लोरेशन के लिए यहाँ पे 1 फास्फोराइट, 1 ग्लूकोनाइट, 1 लेड एंड जिंक एंड 2 कॉपर के ब्लॉक्स जो है वहाँ पर एक्सप्लोरेशन के कार्य के लिए या तो अभी आगामी समय में प्रस्तावित है या कुछ कार्य यहाँ पे चल रहे हैं। नेक्स्ट, हमारा ये एरिया जो है छत्तीसगढ़ का, जो डायमंड के लिए काफ़ी पोटेंशियल माना जा रहा है, जिसमें हमारे पास प्रीवियस एक्सप्लोरेशन वर्क में काफ़ी एक OGPA एरिया जो है वो आइडेंटिफाई है। इसमें पहले से ही हमारा जो फेमस मैनपुर का एंड गरियाबंद का डायमंड, पालीखंड बैराडी का डायमंड ब्लॉक है, और इसके साथ ही इसके जो फर्दर साउथ में भी है, जिसमें गवर्नमेंट ऑफ इंडिया ने डायमंड के लिए इसको एक्सप्लोरेशन लाइसेंस के लिए ब्लॉक को आइडेंटिफाई किया हुआ है। नेक्स्ट, हमारे साउथ छत्तीसगढ़ के इस पार्ट में टिन, लिथियम एंड रेयर अर्थ मिनरल्स की काफ़ी अच्छी संभावना है। यहाँ पे पहले से ही हमारी CMDC से जो एक JV कंपनी है, उसके द्वारा जो है 13 टिन की माइनिंग लीज, छोटे माइनिंग लीज के एरिया उनके पास ऑलरेडी हैं। एवं एक्सप्लोरेशन के लिए यहाँ पे एक लिथियम का ब्लॉक जो है हमने एक प्राइवेट एक्सप्लोरेशन एजेंसीज को, हमारे NPS को अलॉट किया हुआ है, और यहाँ पे लिथियम, आरी और अदर मिनरल्स के लिए वो एक्सप्लोरेशन का कार्य कार्य यहाँ पे कर रही है। हम डायरेक्टर जियोलॉजिकल माइनिंग के छत्तीसगढ़ के स्ट्रेटजिक एंड क्रिटिकल मिनरल्स के एफर्ट्स के बारे में बात करेंगे। तो हमारी सबसे पहली जो चीज़ है वो प्रायोरिटी ऑफ एक्सप्लोरेशन इस समय स्ट्रेटजिक एंड क्रिटिकल मिनरल्स की है। हम इस क्षेत्र में और आगे काम करने के लिए इंस्टीट्यूशनल कोलैबोरेशन के लिए भी काफ़ी ज़्यादा काम कर रहे हैं। हम पीएसयू को भी उनके डाइवर्सिफिकेशन के लिए कि वो स्ट्रेटजिक और क्रिटिकल मिनरल्स पर कार्य करें, उसके लिए भी एनकरेज कर रहे हैं। एंड एनपीएस को भी हमारे यहाँ से काफ़ी स्ट्रेटजिक एंड क्रिटिकल मिनरल के लिए काम करने के लिए एनकरेज किया जाता है। हम अल्टरनेट रिसोर्सेज जिसमें क्रिटिकल और स्ट्रेटजिक मिनरल्स की संभावना होगी उस पर भी काम करने के लिए कोलैबोरेशन या खुद भी काम करने की बात कर रहे हैं। हमने खुद हमारे यहाँ डीजीएम के स्तर पर भी एक एडमिनिस्ट्रेटिव इनिशिएटिव भी स्टार्ट किए हैं हमारे डायरेक्टर्स के इनिशिएशन पे, उस पर भी हम काम कर रहे हैं। नेक्स्ट, हमारे एक्सप्लोरेशन प्रायोरिटीज़ के बारे में यदि हम बात करते हैं तो हमने लास्ट फाइनेंशियल ईयर्स में 24-25 में करीब 68 हमारे छत्तीसगढ़ में विभिन्न एजेंसियों के द्वारा एक्सप्लोरेशन के जो कार्य लिए थे, जिसमें 51% जो प्रोजेक्ट्स थे वो क्रिटिकल एंड स्ट्रेटजिक एंड डीप सीटेड मिनरल्स के प्रोजेक्ट थे, जिसमें जीएसआई के द्वारा 25 प्रोजेक्ट्स यहाँ पे कार्य किया गया था। हमारे यहाँ इन एक्सप्लोरेशन प्रोजेक्ट में करीब 19 वेरियस मिनरल प्रोजेक्ट्स थे, जिसमें लेड, जिंक, गोल्ड एंड डायमंड्स के साथ डीप सीटेड मिनरल्स के ब्लॉक के प्रोजेक्ट हैं। तो 28 क्रिटिकल स्ट्रेटजिक एंड मिनरल डिपॉजिट्स के प्रोजेक्ट्स 2024-25 में लिए गए थे। नेक्स्ट, हमारे द्वारा जो इंस्टीट्यूशनल कोलैबोरेशन के संबंध में कार्रवाई जो की गई है उसमें हमने डीजीएम के द्वारा जो कोलैबोरेशन के लिए एकेडमिशियन से बात की हुई है, जिसमें आईआईटी बॉम्बे, आईएसएम धनबाद और एनआईटी रायपुर को अपने प्रपोजल हमारे यहाँ सबमिट करने के लिए बोला गया है। और वहाँ से साइंटिस्ट ने काफ़ी पॉजिटिव रिस्पांस देते हुए बहुत जल्द ही हमारे यहाँ कुछ क्षेत्रों में क्रिटिकल स्ट्रेटजिक मिनरल्स के लिए एडवांस टेक्नोलॉजी से कुछ वर्क करने के लिए प्रपोजल देने के लिए अपनी सहमति व्यक्त की है। और बहुत जल्द ही हम उनसे एमओयू करके इन हमारे छत्तीसगढ़ के कुछ पार्ट्स में क्रिटिकल स्ट्रेटजिक मिनरल्स पर कार्य करेंगे। डीजीएम का जो पीएसयू के जो डाइवर्सिफिकेशन है, इसके लिए भी हम लोग काफ़ी पीएसयूज को मोटिवेट कर रहे हैं, जिसके तहत हमने कोल इंडिया लिमिटेड एंड मॉयल एंड हिंदुस्तान कॉपर लिमिटेड के साथ ऑलरेडी कॉपर और मैंगनीज के लिए एमओयू किया है, तथा कोल इंडिया लिमिटेड से हम बहुत जल्द ही क्रिटिकल और स्ट्रेटजिक एंड डीप सीटेड मिनरल पर एक एमओयू छत्तीसगढ़ मिनरल डेवलपमेंट कॉर्पोरेशन के माध्यम से करने जा रहे हैं। नेक्स्ट, हमारे इफेक्टिव मोबिलाइजेशन के लिए हमारे कुछ कार्रवाई हैं, कार्य और सजेशन है, जिसमें हम ये बताना चाहते हैं कि हमने जीएसआई से भी रिक्वेस्ट किया है कि वो अधिक से अधिक प्रोजेक्ट हमारे छत्तीसगढ़ में क्रिटिकल स्ट्रेटजिक एंड डीप सीटेड मिनरल्स पर भी लें। डीजीएम खुद भी इस बार यह डिसाइड कर रहा है कि हम कम से कम हर रीजनल ऑफिस के थ्रू कम से कम एक क्रिटिकल स्ट्रेटजिक मिनरल का प्रोजेक्ट पर कार्य करेंगे ही। MECL से भी हमने अपने अभी वर्कशॉप में रिक्वेस्ट किया है कि वो अधिक से अधिक क्रिटिकल और स्ट्रेटजिक मिनरल के प्रोजेक्ट्स एनमेट के माध्यम से लेते हुए हमारे छत्तीसगढ़ में करें। हमारा AMD से भी अनुरोध है कि वो जो अल्टरनेट रिसोर्सेज हैं हमारे यहाँ कुछ, जिसमें टिन के साथ जो स्लैग निकल रहा है या अदर लेटराइट के साथ जो वेनेडियम और गैलियम की संभावना व्यक्त की जा रही, उस पर वो कार्य कर सकते हैं। हमने NMDC से भी अपना डायमंड्स एंड बेस मेटल्स के ऊपर काम करने के लिए अभी काम किया हुआ है। मॉयल से ऑलरेडी हमने मैग्नीज के एक्सप्लोरेशन कार्य के लिए नॉर्थ छत्तीसगढ़ में MOU किया गया है। मॉयल जो है सक्सेसफुली वहाँ पे एक्सप्लोरेशन कार्य कर रहा है और उनके द्वारा काफ़ी अच्छी संभावनाएं और रिजर्व मैग्नीज के व्यक्त किए गए हैं। SCL के द्वारा हम नियर फ्यूचर में वेस्टर्न छत्तीसगढ़ में कॉपर के लिए काम करने जा रहे हैं, जो बहुत जल्दी हमारा एक्सप्लोरेशन का वर्क शुरू होगा। कोल इंडिया लिमिटेड से हम शीघ्र ही एक MOU CMDC के माध्यम से साइन कर रहे हैं, जिसके द्वारा हम क्रिटिकल और स्ट्रेटजिक मिनरल पर स्पेशली अपने स्टेट में काम करेंगे। हमने एनपीए के लिए भी एक्सप्लोरेशन एनपीएस नोटिफाइड प्राइवेट एक्सप्लोरेशन एजेंसीज को भी प्रमोट करने के लिए यहाँ से छत्तीसगढ़ सरकार से समुचित कदम उठाते हुए साउथ छत्तीसगढ़ में कार्य करने के लिए उनको 25% एक्स्ट्रा एडिशनल इंसेंटिव देने के लिए बात की, जिसे भारत सरकार ने मान के इसे नोटिफाई भी किया है। तो हमारे छत्तीसगढ़ में एनपीएस को भी हम अपने वर्कशॉप और अन्य मीटिंग्स के माध्यम से यह बता रहे हैं और उनको प्रोजेक्ट लेने के लिए उनको सहायता भी प्रदान कर रहे हैं। नेक्स्ट, हमारे इस समय हमारे जो डायरेक्टर हैं, हमारे सेक्रेटरी हैं, वो भी लगातार हमारे नोटिफाइड एक्सप्लोरेशन एजेंसी और प्राइवेट एक्सप्लोरेशन एजेंसी से भी मीटिंग कर छत्तीसगढ़ में क्रिटिकल एंड स्ट्रेटजिक मिनरल्स के कोलैबोरेशन के लिए और अधिक से अधिक प्रोजेक्ट्स को लेने के लिए मोटिवेट कर रहे हैं। नेक्स्ट, रिसेंटली हमने अपने वर्कशॉप भी यहाँ पर छत्तीसगढ़ स्टेट में 25 जुलाई को किया है, जिसमें हमारे विभिन्न सेंट्रल एजेंसी जीएसआई MECL के माध्यम से नोटिफाइड प्राइवेट एक्सप्लोरेशन एजेंसीज को हमारे यहाँ अधिक से अधिक प्रोजेक्ट लेने के लिए और हमारे यहाँ की पोटेंशियलिटी को बताते हुए अधिक से अधिक प्रोजेक्ट लेने के लिए एनकरेज किया है। नेक्स्ट, कुछ अल्टरनेट रिसोर्सेज जो क्रिटिकल और स्ट्रेटजिक मिनरल की संभावना है, इस पर भी हमारे यहाँ हमने काम किया है। हमने यहाँ के टिन स्लैग को जेनाडेक से एनालिसिस किया, जिसमें लैंथनम सेरियम और नियोडियम का काफ़ी अच्छी मात्रा प्राप्त हुई है। इसके रिकवरी के लिए और इसके सेल के लिए आगे किस तरीके से कार्रवाई की जानी है, इसकी संभावना पर हम लोग लगातार बात कर रहे हैं और इस फोरम के माध्यम से भी हम ये अनुरोध करते हैं एमडी से कि इसके लिए वह डीजीएम छत्तीसगढ़ से वो समुचित तौर पर गाइड करें। एंड फर्दर हमारे पास जो कोल जो पावर प्लांट्स में से जो फ्लाई ऐश निकलता है, इसमें सिनोस्फीयर्स की भी काफ़ी अधिक मात्रा प्राप्त हो रही है, जिसमें कुछ प्राइवेट एजेंसी जो है डायरेक्टली विदाउट किसी इंफॉर्मेशन के सिनोस्फीयर को सीधे कंसंट्रेट को निकाल के बाहर लेके जा रही है। इसकी भी रिकवरी अधिक से अधिक और कैसे की जाए और गवर्नमेंट को इसको डायरेक्ट सीधे कैसे फायदा हुआ जाए, इसके लिए भी हम लोग कार्य की स्ट्रेटजी बना रहे हैं। हमारे यहाँ का जो एल्यूमिनस लेटराइट है जो हमारे नॉर्थ छत्तीसगढ़ में है, उसमें गैलियम, वेनेडियम और उसके साथ जो बॉक्साइट के एल्यूमिना प्लांट उसमें रेड मट के रूप में बाई प्रोडक्ट के रूप में जो प्राप्त होता है, उसकी भी रिकवरी कैसे की जाए, इसके लिए भी हम लोग विभिन्न एजेंसियों से संपर्क कर आगे के लिए स्ट्रेटजी बनाने की कोशिश कर रहे हैं। नेक्स्ट, हमारे डीजीएम छत्तीसगढ़ में जो एडमिनिस्ट्रेटिव एफर्ट किया है, अभी हम लोगों ने रिसेंटली एक क्रिटिकल मिनरल सेल का भी यहाँ पर एक गठन किया हुआ है, जिसमें किसी भी एजेंसीज को क्रिटिकल और स्ट्रेटजिक मिनरल्स पर कोई भी छत्तीसगढ़ में कार्रवाई करने के लिए या कोई प्रोजेक्ट लेने के लिए किसी भी प्रकार की गाइडेंस सपोर्ट की जरूरत होगी, ये सेल उनको सीधे सहायता प्रदान करेगा। हमारे पास बीच बीच में हम स्टेक होल्डर मीट्स भी करेंगे, जिसमें एनपीएस को या एनईएस को हम अपने प्रोजेक्ट्स लेने के लिए प्रमोट करेंगे। हम जीएसआई के लिए भी हमने काफ़ी अच्छे लगातार मीटिंग कर चर्चा की और जीएसआई अभी नियर फ्यूचर में नेक्स्ट फील्ड सीजन में काफ़ी ज़्यादा स्ट्रेटजिक एंड क्रिटिकल मिनरल प्रोजेक्ट लेने के लिए फोकस कर रही है। नेक्स्ट, हम अपने इन्हीं सब प्रोजेक्ट्स के बारे में एक अपने सक्सेसफुल ऑक्शन की स्टोरी में भी यह बताना चाहेंगे कि हमने अभी तक जो 51 ब्लॉक ऑक्शन किए हैं, जिसमें से 38 ब्लॉक बल्क मिनरल्स थे और उसमें से 10 क्रिटिकल मिनरल्स ब्लॉक हमारे छत्तीसगढ़ में अभी तक ऑक्शन किए जा चुके हैं, तथा 3 जो है डीप सीटेड मिनरल हैं। अभी वर्तमान में 9 ब्लॉक लाइव है, जिसका बिड आज समाप्त हुआ है और हमने इसके साथ ही 6 टिन के ब्लॉक खुद यहाँ पे बस्तर रीजन के जीएम बनाकर गवर्नमेंट ऑफ इंडिया को सौंपा है, जिसपे नियर फ्यूचर में ऑक्शन की तैयारी चल रही है। ये हमारे 10 ब्लॉक्स हैं जो हम ऑलरेडी स्ट्रेटजिक एंड क्रिटिकल मिनरल्स एंड के ऑप्शन यहाँ पर छत्तीसगढ़ में कर चुके हैं। इन पर काफ़ी अच्छी फाइनल बिड प्राइस प्राप्त हुई है। खास तौर से यदि हम ग्रेफाइट और वेनेडियम की औरंगा रेवतीपुर ब्लॉक के बाद में नंबर 8 पर देखेंगे तो 189% की हमें फाइनल बिड प्राइस प्राप्त हुई है, जो कि कोल इंडिया लिमिटेड ने हमारे यहाँ लिया हुआ है। नेक्स्ट। हमारा ये एक्सपेक्टेशन जो इस एरिया में है, जो हमारे डीजीएम के एक छोटा एक कम एक्सपीरियंस के कारण है, हम ये आप लोगों से आशा करते हैं कि हमारे पास काफ़ी चैलेंज है इस क्षेत्र में काम करने के लिए। तो हम AMD, GSI और IBM जैसी बिग एजेंसी जो इस क्षेत्र में काफ़ी एक्सपर्टाइज रखती है, उससे लगातार टेक्निकल हेल्प, असिस्टेंस, एक्सप्लोरेशन प्लानिंग, वर्क मॉनिटरिंग, रिसोर्स ऑडिटिंग, रिपोर्ट स्क्रूटनाइजिंग, कैपेसिटी बिल्डिंग एंड बेंचमार्क एंड बेस्ट प्रैक्टिस ग्लोबली के लिए बात करते हैं। हम अपने ब्लॉक को लगातार ऑक्शन तो कर रहे हैं, और जो प्राइवेट एजेंसी यहाँ पे कंपोजिट लाइसेंस में काम कर रही है, उनके वर्क को सीधे तौर पे कोई भी मॉनिटर कर नहीं पा रहा है, क्योंकि वो अपने जो प्रोस्पेक्टिंग स्कीम्स हैं, वो स्कीम या तो IBM को देती है या फिर DGM को देती है। परंतु हमारा सोच ये है कि इसके लिए हम एक नेशनल लेवल क्रिटिकल मिनरल एक्सप्लोरेशन एंड डेवलपमेंट कमेटी का गठन करें, जिसके अंतर्गत हम अपनी इन एजेंसीज को, जिनको हमने कंपोजिट लाइसेंस दिया हुआ है, उनको समुचित तौर पर गाइड कर सकें, उनकी रिपोर्ट्स और उनके प्रॉस्पेक्टिंग वर्क को मॉनिटर कर सकें, उनको वो जो रिपोर्ट फाइनली सबमिट करते हैं उनका भी रिव्यू भी कर सकें कि उन्होंने वास्तव में वो जो कंपोजिट लाइसेंस उनको दिया था, उन्होंने काम पूर्ण सही तरीके से किया है या नहीं किया है। एंड पीरियडिकली उनकी जो वर्क है उसका भी हम अपना पब्लिक स्टेटस भी दे सकें। तो हमारे इस फोरम से एक ये सजेशन है कि हम क्रिटिकल और स्ट्रेटेजिक मिनरल के डेवलपमेंट के लिए एक CMEDC टाइप एक कमेटी गठन करें, जिसमें GSI, AMD, IBM, MECL एवं कंसर्न स्टेट गवर्नमेंट के मेंबर्स को रखना होगा, और इन मेंबर्स की कमेटी के द्वारा उस स्टेट में जो भी कंपोजिट लाइसेंस या जो भी माइनिंग लीज ग्रांट की जा रही है, उसका समुचित हमको मॉनिटर करना आवश्यक है, ताकि हम अपने क्रिटिकल और स्ट्रेटेजिक मिनरल की जो हमारी संभावना है उसको पूर्ण रूप से साकार किया जा सके। नेक्स्ट। थैंक यू वेरी मच।
Thank you, sir. You have taken us through a fascinating path by which Chhattisgarh is taking India towards self-reliance in terms of critical and strategic mineral resources in alignment with our Vision 2047. Thank you for your time, sir. Please accept a small token of appreciation from our side at your office that we will be sending. Thank you very much, sir. So now it's time to move to our penultimate lecture today. Our next speaker, Srikant R. Manthanwar, Regional Director, AMD Central Region, is an experienced geologist with vast experience in uranium and rare metal exploration. His keynote address will shed lights on exploring atomic and
for Exploration and Research, Central Region, Nagpur, a constituent unit of Department of Atomic Energy. He graduated PhD degree from RTMNU, Nagpur University, and MSc Tech in Applied Geology from MTech and MTech in Mineral Exploration in July 1989 from IIT ISM Dhanbad. He joined AMD in August 1989. He has a vast experience of exploration and research of atomic minerals in different geological in the state of Arunachal Pradesh, Rajasthan, Chhattisgarh, Madhya Pradesh, Maharashtra, and Odisha. He has multiple in journals and symposiums of national and international repute. He has also opened up Lathi sandstone, a potential host for sandstone type of mineralization. In his initial days, he worked in the albitite line. Now it has become Rohil deposit of North Delhi cold belt. He has also worked in Arunachal Pradesh, where he has established many areas in tough geological domain. And most contributing thing is he is the only geologist of AMD and probably in the geology fraternity who has done his field work in the easternmost village of Arunachal Pradesh. Now, may I request our Honorable Regional Director Sri Srikant R. Manthanwar for his lecture.
Hello. Namaskar. Shubha Sandhya. I'll be presenting a article on exploring atomic and associated critical minerals in central India, integrated and futuristic approach. See, my theme of my presentation will be exploration, that will be for atomic minerals, associated critical minerals. So the way forward will be integration of futuristic trends. इसके पहले मेरे पहले काफी चर्चा हो चुकी है जिसमें क्रिटिकल मिनरल्स के बारे में और एटॉमिक मिनरल्स के बारे में भी कहा गया है मेरा अप्रोच रहेगा सेंट्रल इंडियन जियोलॉजी के ऊपर so exploration of atomic and critical minerals so what are atomic minerals most of the people sitting over here knows it well so that Atomic Energy Act 1962 stated that atomic minerals are substances including minerals and their derivatives that the central government specifies as being potentially useful for the production or use of atomic energy or related research. In 2023, there was Mines and Minerals Development and Regulation, that was MMDR. It has stated that for specifying these atomic minerals particularly, like rare earths group containing an uranium and thorium, phosphorite containing uranium, pitchblende and other minerals, uranium bearing and thorium bearing sand minerals, tailings from ores after extraction, and beach sand minerals. So these are being considered as atomic minerals. What are critical minerals? So everyone here is hearing since morning about this. So they are essential for our economic development and national security of a country. There are two main parameters, the economic parameters and the supply risk. Because their limited availability or concentrated extraction and processing in a few geographical locations can create supply chain vulnerabilities or disrupt critical industries. This is well known, like some geographical locations, they are having higher concentration, higher, like for an example, China. So that condition comes here. That's why supply risk. So these are the minerals which are being considered as the critical and strategic minerals. I need not to read it. It has been dealt this morning. So why these are important for India? Because these critical minerals are the foundation of modern technology, having a wide applications like say electrical vehicles, medical applications, solar panels. And most important is net zero emission transition and Atmanirbharta will be self-sufficient. There are 5 pillars of this critical mineral value chain: geoscience and exploration. In that, participation of the private sector as exploration agencies under NMET. Then mineral extraction, intermediate processing, advanced manufacturing, and recycling. So, coming to the main geological domain, where shall we look for these minerals? We all know we have proterozoic rocks, crystalline rocks, Gondwana sandstone, which can have uranium potentials, monazite rich sands, placers, and other geological formations will be rich in thorium, and lithium naturally we get it from mica belts in central India, pegmatite deposits. If you think other, there are brines, but we don't have any brines in central India as such. What are associated critical minerals? They are rare earth element, beryllium, graphite, cobalt, niobium tantalum, vanadium, and zircon. I'll not tell in details about their geological domain for this. It's been self-explanatory in my presentation. What are the geological domains of central India, the favorable loci for mineralization? We have 2 cratons like the marvel of geology in central India. We have Buster Craton and the Bundelkhand Craton. And we have CITZ, that is Central India Tectonic Zone, which lies between Son Narmada North Fault and in the south between CIS. That has been explained there, what is there in that CITZ, what I said just now. Then the supracrustals, the Mahakoshal, Betul Belt, Saucer Belt. We have granulite belt, and we have 9 proterozoic basins in central India, like Vindhya and Chhattisgarh, Khairagad, Indravati, and so on. There are total 9. And we have another Chotanagpur granite gneiss, which is having in this part. So that is also hosting uranium deposits. And the favorite one is our Kotri Dongargal belt, which can give us the granite-related mineralization. In addition to that, we have Phanerozoic basins like Satpura Gondwana Basin and the Son Mahanadi Basin and infratapians. So geological domains of central India, cerebral loci for various type of uranium mineralization. Like Nandgaon Khairagar Basin, that is the Kotri Dongargarh, where just now I said Bijli highlight the volcanic related Bortala formation from proterozoic sandstone type. CGGC, we are getting migmatite leucosm hosted. Then Betul crystalline, we can look for structure control metamorphite type, and we're looking for it. Vindhyan Basin, Vindhya and Chhattisgarh and Indravati, these are proterozoic basins which are very good for unconfirmated uranium mineralization, and naturally the Gondwana Basin, which is good for hosting sandstone type of mineralization. In central India, we have 5 uranium deposits. Out of these 5, 4 lies in the state of Chhattisgarh, while one Mogra is in the state of Maharashtra. Coming to the details of these deposits, like Bodal, we already proved 1530 tons hosted in the metamorphite type Chitapani andesite. Then Bijli highlights, we have proved Bandari Tola 518 tons, Mogra 355 tons, Jajawal 1438 tons, and Tumat Dhabi 500 tons of deposit has been proved in central India. Now coming to the rare earth deposits, central India is also bestowed upon with this. So in the North Odisha mobile belt, we are getting niobium-rich columbite tantalum and beryl. In the Bastar Malkangiri pegmatite belt, tantalum-rich columbite, tantalite, and beryl again. In the Sarguja crystallines, niobium-rich columbite, tantalite, monazite, other RE minerals, and saucer pyridinites, niobium-rich columbite, tantalite deposit. In central India, central region and central India, we have riverine places. That's only kind of a riverine place in India where we are getting it. That's the Siri River Basin, Siri, Kanhar, and Sindhu River Basin. And we are getting genotype bearing polymineral concentrate from these inland places. Now, evidences of associated critical minerals with these domains. In CGGC, we are getting associated graphite, lithium, and cesium. Younger basement rocks of Singhora sediments are rich in molybdenum. In Bastar Malkangiri pegmatite belt, where we are getting tantalum, niobium tantalum, they are associated with tin and zirconium. Betul crystallines, we are getting graphite, that is a place Sonaghati. So nearby that, Gauthana, Sonaghati, huge, along around 3 kilometers long graphite belt is exposed. Windens, we have phosphates. And Mahakaushal, again, we are getting vanadium. Now coming to the integrated and futuristic approaches. The conventional approach, what we are doing now, is like we carry out aerial surveys, multispectral data, aerial photographs. Then we carry out radiometric surveys by sodium iodide thallium activated detectors. They are indigenously made in our organization only. We carry out geological surveys, we carry geochemical surveys, we carry geophysical surveys. And then we go for drilling, that is vertical and inclined drilling. This narrows down the target area. In addition to this, we carry out find audio lithograph, that is CN film study, logging, and reserve estimation by conventional methods. In addition to this, we have other laboratories like physical gamma ray spectrometry, beta gamma, and chemical AAS, ICP-UAS, and others. In addition to that, we have XRD and XRF studies. These are conventional. What will be the futuristic approaches? And why we require this? The traditional mineral exploration methods are often time-consuming, capital-intensive, and they're constrained by the human interpretation while dealing with complex and multi-dimensional geological data sets. With the emergence of artificial intelligence and machine learning and data-driven methodologies, by integrating and analyzing large multi-source data sets in GIS platform, artificial intelligence and machine learning algorithms can be used to detect subtle geological patterns, anomalies, and structural features, which will be helpful for mineralization to understand the mineralization patterns, which are complex and nuanced, to be discerned by conventional method. It can't be done by conventional method. So what should be the methodological framework? So it should be data-driven, knowledge-driven. Both approaches can be considered. So coming to the futuristic approach, we can go for a drone-based surveys. The places where unable to the approach is not proper, like for an example, I'll say in Arunachal Pradesh, where the terrain is tough, one can't go. In this case, a drone can be used to get a data. Remote sensing studies with the hyperspectral data studies. For radiometric studies, we are using sodium iodide crystal. Then we can go advanced detectors, that is LABR, cerium activated crystals. Then surveys with the human brain, if we add up artificial intelligence, and machine learning for lithostructural mapping. Geochemical studies can be better at the spot can be taken with the help of a portable XRF machines. We can use LIBS and other technology-driven portable geoanalytical techniques. For geophysical studies, we can go in an advanced way using EMT seismic surveys to penetrate and get data from the deeper levels. We can use, instead of the vertical and inclined drilling, we can go for a directional drilling where it will be cost effective. Logging, we can go for PFN logging and ore reservation estimation, where we do by simple methods. There we can use geostatical estimation based on 3D ore body studies configuration using advanced geological software. In addition to that, like other technologies in the physics and the chemical way, HP germanium detectors, alpha detector, INA labs, chemical, LAICPMS, TIMS, and like we can go for shrimp and scanning probe, electron microprobe analysis. Then comes the thing where we are data driven, knowledge driven, and hybrid. In a data driven, it is being done by the machine. It identifies data, patterns from data using statistical analysis and algorithms. Here, there may be you may get the black box syndrome, paradox. The black box paradox effect will overlook, because since it is the machine learning, the black box paradox may overlook the geological significance. And data driven is good for the brownfield areas where we have a large data. So that can be useful in brownfield area. When we go to the greenfield area, the data driven, it is based on the expert geological knowledge and conceptual modeling. In this, there will be a data scarcity, interpretability, handling uncertainty, adaptable to diverse geodata, but is potential for expert bias. Because when you are handling this data, a person gets biased and he will have his own thinking on that particular area, because the data is limited and very strong conceptual model, so that it holds good for greenfield area. But when we come to a hybrid thing, when the data driven and the knowledge driven comes together, then the interpretation will be good, because a person won't be biased, a human brain won't be biased, because he's getting certain data from AI and ML with that algorithms, and it can be used. The brain can be used to understand, because AI ML can't understand the geological scene. What a geologist, a person knows, the machine doesn't understand. There, your human interface works. So when you use the hybrid data, hybrid mode, so that will be good for combining both brownfield and the greenfield insights, and we can have a mixed data availability. So with this approach, where can we look for in central India? For QPC type, we have Beladilas, Pengpals, Sukmas. So here we can go for litho, pedo, thin sediment surveys and then further enhance it. Like metamorphite type, we can use We can go to select the areas like Nandgaon groups, Bilaspur, Raipur, Sarguja crystallines, CGGC. Here we can use first the aerial survey, then magnetic and electrical, that use of geophysical surveys in that. I said in central region is endowed upon with 9 prototype basins. So to look forward unconformity type of a uranium mineralization, these Purana basins, Vindhya and Chhattisgarh, Indravati, Pakhas, can be looked for, considering the integrated and futuristic approach. Volcanogenic, that is Bijli rhyolite, Kotri Dongargarh belt, where geophysical surveys can be used. Intrusive types and granite related, where we are already working, but to enhance our interpretation, we can sophisticated technology, we can use our large data by AI/ML algorithms. Sandstone, like to look Gondwanas below Deccan traps. So for that, we will require seismic surveys, deep drilling. So coming to the conclusion, what a nation needs: atomic and critical minerals for energy transition. Vikasit Bharat 2047 towards clean energy, and for positioning itself in the world of modern technologies. Central India, I just said, Central India is endowed with geological potential for hosting atomic and critical mineral resources. Recent regulatory changes implemented by Government of India will provide impetus to accelerated and collaborative exploration efforts of these minerals in Central India, like NMET and everything is coming up, so that will be very good. And conventional method, integrated phase-wise methods, due to complexity in the geological process, futuristic approaches holds merit. Thank you.
Thank you, sir, for your detailed explanation of how emergence of new technologies like AI, ML, and data-driven methodologies combining with the expertise of the subject experts can offer a paradigm shift in identification and evaluation of atomic and critical mineral resources landscape of Central India. Now, I would like to request our Honorable Additional Director, Operation 2, Sri P.K. Sharma, sir, to present a token of love to our speaker, sir. Thank you, sir. It's now time to move on to our last presentation of today. This is a scientific paper titled A Low-Cost Recovery of Hydrogen Using Low-Energy Lasers, a case study of natural fluid inclusions from Central India. To present this paper, we have among us today Dr. Kirti Kumar Randive, Professor and Head of the Department, PGT Geology, RTM, Nagpur University. He is a renowned academician and is known for his keen interest in research and development activities, apart from being a popular teacher and mentor to his students. Sri Pritham will give us a brief testimonial about our speaker.
Namaskar. Dr. Kirti Kumar R. Randive is professor and head of the department at the postgraduate Department of Geology, RTM, Nagpur University, Nagpur. After completing MSc, he served the Geological Survey of India and then joined the department as a regular faculty member in 2003. Since then, he strengthened research and development activities and made several publications in high impact journals, also authored 2 monographs and edited 10 books for renowned publishers including Springer, Elsevier, and Digurius. He is the editorial body member of the Springer Nature Journal Mineralogy and Petrology and deputy editor-in-chief of Nagpur University Science Journal. He was invited as a visiting fellow to the University of Portsmouth, UK. His contributions were applauded on various platforms. Now may I request Dr. Kirti Kumar R. Randhiveset to kindly deliver his lecture.
Good evening, one and all. It's a great privilege to stand in front of you all who are working so hard for the critical minerals. The mission, the buzzword nowadays is the critical minerals. I will take you to a little journey of the accidental discovery of something which is quite significant, and you will know through this presentation that how a simple work that we have started with very limited resources and how it has become something which has to be reckoned with. In the previous presentation, Manthanwar Sahab has mentioned about the green energy mission, and I will continue that thread only. So I will be talking basically about the low cost recovery of the hydrogen using low energy lasers. You will know what it is. Can I have the next one? Now, why hydrogen is the energy that we are looking as the future fuel? It is important industrial feedstock which is used for the desulfurization of and hydrocracking of oil used in oil refineries and production of ammonia and methane. It is the prospective emission-free automotive fuel. Although we know that hydrogen is most abundant element in the universe, but the terrestrial resources of molecular hydrogen that we need as a fuel are negligible, and it is often combined with carbon, oxygen, and sulfur in nature and form hydrocarbons and hydrosulfanes. So most industrial demands are means how to separate that, because it is in the compound form and we need the molecular hydrogen. So either it is in the form of hydrocarbons or hydrosulfanes. So what we do, what has been done traditionally is that most industrial demands are recently covered by the production of hydrogen from natural gas by a process called as steam methane reformation or SMR in the several plants. The gaseous hydrogen sulfide is particularly suitable for hydrogen production. That means the hydrogen sulfide is something that is used, and the reason is that the standard enthalpy of formation of hydrogen is 298, which equals to minus 20 kilojoules per mole. In the H2S gas, it is less than that of methane and water. Now, what about this steam methane reforming process or SMR process? In this, what we do, it is the two-stage process. In the first stage, the primary reaction that is methane CH4 plus water is treated, and in return, what we get is carbon monoxide and molecular hydrogen. But then that occurs at very high temperatures, that is between 700 to 1100 degrees Celsius. It produces hydrogen and carbon monoxide. Then that also used in the secondary processes, in which the carbon monoxide again treated with hydrogen, which gives rise to the carbon dioxide and hydrogen again. So this is how we get more recovery of the hydrogen. That is one thing, one good thing. But then there are two things which are also related to that, and these are the limitations of this SMR process. First and foremost, it has very high operational costs due to its catalysis and design. Secondly, it emits the very harmful greenhouse gases, carbon dioxide, carbon monoxide. The natural methane gas often contains hydrogen sulfide H2O, which is called as SQNG, that means sub-quality natural gas. Now, which is also called as sour gas. So people related to this industry, oil industry, they are aware of this sour gas, which has hydrogen sulfide more than 4 ppm, then that becomes very, very toxic. H2S is poisonous catalyst and highly toxic, therefore its removal is important. That means although we are doing this SMR process only, hydrogen we are recovering, but it is coming with high costs. Now that sour gas has also to be treated, and that is treated in the Claus process. This Claus process is something like the hydrogen sulfide combined with sulfur dioxide. We get elemental sulfur plus water. So hydrogen in methane is burned, and H2S bond hydrogen ends up in the wastewater, and similarly SO2 is removed in the tail glass cleanup units. So altogether, this is a toxic process, but then this is what we have. Now the technological challenges are there. First is therefore an emission-free hydrogen production is a major challenge, and need for alternative to SMR and the Claus processes is also very important. And the goal is to recover the hydrogen without generating the waste gases. This is what is needed today. Now I was mentioning earlier when I started the presentation that we made a very humble beginning. It was this area. This area is a Bastar crater. We had some green mica bands. And this student, she was doing her dissertation, so we have given her topic to this. I think Dhanashri or maybe knowing Ram. So it was her dissertation work. We started working on this, and then what we noticed was the presence of the chrome-rich muscoid and chromium-rich green mica quartzite. While we were doing this, we published this paper that time, and while we were doing, we come across the fluid inclusions and the tracks. Also, because this was the metasedimentary, so we got lot of detrital minerals also, including zircons, monazites, tourmaline, rutile, and all those there plentifully. So we thought of doing more work on that. So then some of my colleagues in Slovakia, I contacted him, Professor Bratislav Hurai. He is considered as the authority, one of the authorities in fluid inclusion studies. So with the help of him, we studied this fluid inclusion. So what we found that these fluid inclusions are sulfur-bearing fluid inclusions in quartz, which are irregularly distributed with graphite, muscoid crystals, and all that. So based on that study, we have published this paper in chemical geology. During this, what happened is that there were some discoveries made. The sulfur-bearing methane inclusions up to 68% of molecular hydrogen sulfide. This is hydrogen sulfide is the gas we take in the SMR process, and we do it. So we got a natural host in which we had this H2S. And while we were doing more studies, especially the Raman, when we were performing the Raman studies, so we use the green lasers. So what was found that the vibration modes, which are given a little bit technical, just bear with me. So they H2S gas and methane at 2609 per centimeter lasers were associated with it, and some unknown Raman bands were also found. And these are the people, one from chemistry and one from geology background. They were experts in this, so they had done some experiments on this. So what was observed initially is that the fluid inclusion generate the molecular hydrogen and surplus sulfur during irradiation using the 532 nanometer 25 milliwatt laser, which indicates the photolytic breakdown. Now, what we want to say, the initial target H2S gas, it was excited with the green lasers, and these green lasers had this energy. What was found was a lot of elemental sulfur and the hydrogen. Both were associated with these bands and some phantom bands also. So the important conclusions during this study is that the polysulfanes are documented for the first time in the natural CH4 H2S inclusions with or without S8 enclosed in the Archean quartzites of the Bastar craton. Then the quantum chemistry modeling based on the density functional theory confirmed that the intense Raman bands of this recorded in the fluid inclusions reflect the vibrations of respective hydrogen bonded as well as non-hydrogen bonded SH stage of the H2S2 up to S8. Means these are polysulfanes H1S1, H2S2 like that, HNSN. So those were present there, and they were, after the lasers were shoot on them, they were breaking down. So the intense, these bands correspond with the vibrations of H2 and H2S2 dissolved in the crown-shaped cyclo-octasulfur, pure sulfur, which was liberated from the H2. So representing quenched and the recrystallized sulfur melt. So the laser-induced photolysis, the process was photolysis, which was operating. So laser-induced photolysis resulted in the massive liberation of molecular hydrogen and the precipitation of newly formed sulfur. So that was basically what was discovered at that. Then we wanted to know these fluids, whether they belong to a particular age or not. I was also mentioning that we got a lot of detrital minerals there. So another collaborator, a story from the University of Portsmouth. So while I visited that time, so we made some analysis, and what we found was this: remarkably coherent population, two populations, we got 3.4, 2.45 zircons. So within that bracket, we found that these are definitely the Archean and the early Proterozoic or mostly Archean, late Archean type of metasediments. And so that was confirmed. So based on that, some fluids were selected, and the H2S splitting was observed in total of the 3 sulfur-bearing inclusions, which were marked as, I mean, those were the numbers which were given to the particular fluid because there are many. So these were the experiments, the confocal Raman spectrum that was used, mentioned here. Main observation. So the molecular hydrogen sulfide in natural gas inclusions enclosed in quartz was transferred into HCH4 mixture with negligible H2S concentration after short irradiation. Means you are shooting the laser, but how much time that laser shooted on those inclusions? So some lasted mostly less than 100 seconds up to 6 minutes, associated with the photoactivated sulfur of this particular 530 nanometer photons emitted by 25 milliwatt neodymium, yttrium, aluminium, garnet laser. What was observed as much as 57 mole% of H2O dissolved in CH4 was converted into hydrogen and sulfur in sulfur-bearing inclusions, whereas the composition changes did not occur in the sulfur-free inclusion. That was one of the observations. What was. And the density functional theory-based calculations corroborated with the existence and breakdown of the sulfur-bearing polysulfanes, which provided accelerated hydrogen radicals capable of breaking the sulfur-hydrogen bond surrounding molecular hydrogen sulfide. So what was observed? Basically, it was mentioned in this 3 that the complex banding in the SH stretching vibration region faded out during the elimination of the sulfur particles with green lasers. So SH bond breakdown occurred within 100 to 400 seconds, except for inclusions which sustained about 6 minutes long irradiation. Some only occasionally sustained for more time, but basically between 100 to 400 seconds, those were broken down. So not only the SH bonds in the sulfur, but also those of the non-bonded molecular H2S in the surrounding gas completely disappeared. Interaction with the green lasers. The photolysis of sulfur-bearing compounds has been accompanied by the liberation of hydrogen, as is documented by the intensity increase of this range. So, how we concluded? In conclusion, the photoactivated sulfur supported H2S photolysis combines benefits of the hydrogen recovery and with deactivation of toxic and corrosive H2O pollutants. And as such, it could serve as the model for environmentally friendly and economically viable source of natural gas. Really, what was mentioned is that the SMR process and the supporting clause process we need not go. What we need is the green laser. I mean, we were able to convert them to break down into molecular hydrogen as well as sulfur. So this is something which has great significance. This is the team professor also. Then publish this result. The applied geochemistry time. Thank you very much for your patient listening.
Thank you, sir.
सर मेरा क्वेश्चन जो है आपने जो जिरकन बोला आर द जोन जिरकन तो सर जोन जिरकन का अंदर आपको जो फ्लूइड इंक्लूशंस मिला है वो तो किस में अच्छा क्वार्ट्ज का अंदर जो मिला है फ्लूइड इंक्लूशन वो प्राइमरी है या सेकेंडरी है हाँ तो सर सेकेंडरी से ये हो रहा है या प्राइमरी से हो रहा है उसको कैसे डिफरेंशिएट कर रहा है
From the primary fluid inclusions. I will share paper with you.
Okay, sir.
दोनों पेपर आपसे शेयर करता हूं.
Okay, sir.
This is very interesting research. Please take it up further.
Okay, sir. Thank you.
Thank you, sir, for sharing with us the novel concept of a simple, catalyst-free and eco-friendly alternative method of clean hydrogen production at room temperature with the potential to revolutionize clean energy production. Once again, I would like to request Sri Srikant Arvanthanwar, Regional Director, MD Central Region and Chairman, Organizing Committee, ACMR 25, to present a token of appreciation from us to our speaker, Sri Kirti Kumar R. Thank you, sir. As we draw this workshop to a close, it's time for the valedictory session. We hope today's workshop has sparked new ideas and fostered valuable collaborations. Although we had a feedback session scheduled, but because of shortage of time, we have to cut short the program. Now we thank all of you for your participation, thoughtful discussions, and commitment to advancing knowledge in the critical area. We hope the connections and insights gained today will continue to grow into an impactful collaboration. We have got our email ID registered, so please share your valuable feedbacks with us that we can incorporate in our future endeavors to make our program more correct. Now it's time for us to express our gratitude to some of our senior officers who made this event a success. So I'd like to request Sri Manthanwasa, Chairman Organizing Committee, to come on the dais to felicitate them. So first of all, I'd like to call on stage Sri Rajiv Ranjan, convener of this workshop. A huge round of applause for sir to make this event a success. Thank you, sir. Now I request Dr. M. Sridhar, Chairman, Organizing Secretary, ACMR 25 to come on dais. Next, I request Dr. V. Ramesh Babu, Chairman, Editorial Committee, to come on to the stage. Now, Sri Chandrasekhar R. Khorge, Chairman, Stage Management and Member, Editorial Committee. Thank you, sir. And now I request Sri PSC Pandit, sir, to come on to this. Thank you, sir. Last but not the least, I request Srimati Sujata Mudliar ma'am, Head Engineering and Services Group, AMD, to come on to the dais. She played a very crucial role starting from the very beginning for the construction of today's inaugurated Dr. D.N. Wadia Auditorium. A huge round of applause for ma'am. Thank you, ma'am. Thank you, sir. Thank you all. I'll once again request Chairman, Organizing Committee, Sri Srikant Manthanwa, sir, to come on dais and felicitate Sri Rajesh Singh, sir, who came all the way from Hyderabad for today's program. Big round of applause for Rajesh Singh, sir. We wish everyone a safe journey back and continued success in your work. Let's keep exploring, innovating, and building a sustainable future together towards a resilient, resource-secured India. With the permission of the chair, now I request Dr. V. Ramesh Babu to propose the vote of thanks.
A very good evening to you all. It is indeed a great honor and privilege for me to deliver the vote of thanks on behalf of organizing team at the conclusion of this highly enriching, thoughtful, provoking workshop on Geological Insights from Central Region. At the outset, I extend my sincere gratitude to our beloved director, Sri Dheeraj Pandey Saab, and chief guest of this function and chief patron of this workshop for his visionary leadership and unwavering support in making this event possible. I also thank the P.K. Sharma Saab, additional director and patron and guest of honor of this workshop, for his continued motivation for making this program successful. I also thank who virtually joined Sri Mayank Agarwal Saab, Additional Director Operation 1, and Sri K.L. Mundra Saab, Additional Director R&D, for their encouragement throughout this. I am especially grateful to Sri Srikant R. Manthanwar, Regional Director, Central Region, Nagpur, and Chairman of this workshop, for his foresight and consistent encouragement
that helped in shaping the success of this event. My sincere appreciations also goes to Sri N.K. Panda, head BMAG, for his timely support and coordination from Hyderabad. My sincere thanks to Sri Rajiv Ranjan, convener, and Dr. Sridhar, organizing secretary, for their meticulous planning and smooth coordination. On behalf of the entire AMD fraternity and the organizing committee, I extend heartfelt gratitude to all our distinguished delegates, invited experts and participants from various premier scientific organizations, exploration agencies, academic institutions such as PSI, MECL, JNA, RDDC, ERI, NRSA, MRSAC, Raman Science Center, RTMN University, Pune University, IBM, CGS, CMR, CMFRI, CMPDL, and Directorate of Geology and Mines from Chhattisgarh, Maharashtra, and Madhya Pradesh. Many of them are virtually joined this workshop. I thank all of them. Your presence enriched this workshop immensely. A special note on appreciation to our entire speakers and panelists whose insightful presentations and deep scientific understanding have significantly broadened our knowledge of Central India's geological landscape, particularly in the context of atomic minerals and critical minerals. Your perspective on exploration strategies, resources potential, and technological innovations have opened promising avenues for future research and collaboration. Heartfelt thank you to the retired doyens of AMD present here today. Your years of dedication and service have laid the strong foundation on which we continue to build, celebrating 75 glorious years of AMD's achievements. We are equally grateful to all our participants, researchers, scientists, and representatives from various organizations for your active engagement, thoughtful questions, and enthusiastic contributions, which added great value to every session. My sincere appreciation to the organizing team, the technical staff, the entire engineering service group, especially Ms. Sujata Mudaliar Madam, Head Engineering Services Group, and Mr. Rajesh Singh, in charge Engineering Services Group from Hyderabad, who joined this occasion. The media personnel, rapporteurs, and all our volunteers whose hard work behind the scenes ensured the flawless execution of this workshop. I thank all the officials who joined the workshop virtually through WebEx across the country. And finally, a warm thank you to every individual who contributed in any way, be it through administration, accounts, security, logistics, or other support services. Your collective efforts have truly made this event a grand success. As we conclude, let us take forward the discussions and collaborations initiated here today, and we together work in the spirit of national service towards atomic and critical minerals self-reliance and sustainable development in alignment with the vision of Vikasit Bharat. Thank you once again. Jai Hind.